Alrighty, so hello and welcome. Howdy. Here we are again with another question. Oh man. Oh. Interviewing is rough. Well, we'll get right into it. Yeah, it's fine. So I'm pretty sure this is an SQL question. Let's take a look. There was a question I was looking at earlier today that's probably similar, if not the same. And I was really annoyed because there was a lot involved and it's frustrating. But it was related to SQL. Yeah man, I just like, it takes, it's kind of a lot of practice you need with SQL questions in order to solve them really quickly. I just don't have that much practice. So I was frustrated because one of the interview questions was about SQL. Basically, it was like one of these, like an SQL hard question. Oh, okay, interesting. Alrighty. ID, name, salary, department. ID is the primary key column for this table. Department ID is a foreign key of the ID from the department table. Each row of this table indicates the ID, name, and salary of an employee. It also contains the ID of the department. Okay. Employee table, department table, ID name, primary key column for this table. Each row of this table indicates the ID of a department and its name. Okay. So we have ID name, salary, department ID. Company's executives are interested in seeing who earns the most money in each of the company's departments. Each high earner in a department is an employee who has a salary in the top 3 unique salaries for that department. Write an SQL query to find the employees who are high earners in each of the departments. Return the table result in any order. Query result format is in the following example. So imagine you had 10 minutes to solve this. That's right. If you had 10 minutes to solve this, how would you do? Who knows? Who knows? So employee table, department ID, salary name, ID, department table, ID, name, output, department, employee, salary. Okay, interesting. IT department, Max earns the highest salary. Both Randy and Joe earn the second highest. Will earns the third highest unique salary. These aren't unique salaries then, by the way. Okay, so, I see. All right. Oh, that's interesting. Ooh, that's tricky. I see the point. It's not just the top 3 earners, period. It's anybody that earns a particular salary number will be included in that list. And we're going to do it per department. Alrighty. Sales department, Henry earns the highest salary, Sam earns the second. There is no third highest as there are only 2 employees. Okay. So basically, I think what you're going to want to do is unique the salary column and take the top 3 salaries and then take anybody who matches those salaries. And you can maybe join on the table, back on the table. So how do we get, so a few things to consider. How can we get the salaries and the employees with those salaries? And we also want to go by department too. I want to break this up. So we can have a subtable that's like we can, I guess, partition sort of. There's a way to do this. We want to group by the department ID, and then the tricky thing, and then we're going to run a routine on each. So like this is the thing with SQL. Like I have no idea how to do this. Like I have not a clue. I have like guesses how I might do this, but overall it's like. So I think also maybe I'll raise this a little bit so that we can lower my voice because I don't like to talk that loud. I do tend to talk loud, but I don't know. Let me sort of talk normally. Excuse me, I think I'm gonna turn this up. Anyway, yeah. So what are we thinking here? So I don't have a clue. I have to sit and think about this for a while. So I know I think part of this too is like just knowing just SQL syntax in the first place. It's a pain in the butt. It's a pain in the butt because I really don't know very much about MySQL. And browsing the docs as well. Alrighty, so language structure, okay. Data types, functions and operators, SQL statements. Yeah, okay. Data manipulation statements. Select. Subqueries. Row subqueries, correlated subqueries, derived tables. So I don't know what we can do to solve this. Like I could maybe do this on one section where, I don't know, you create, like one approach maybe would be first just like only consider one department with one department ID and then try to get a unique list of the salaries, and then try to get all of the rows that match those salaries. Obviously, somehow we want to do this by department. So one of the really challenging things with SQL in this kind of context is that, like, you're only allowed to do this on one line of SQL code, which is like absurdly difficult for no good reason, quite frankly. I guess it shows your prowess with SQL, but like it's also kind of dumb because, like you normally could use, like, there's other like SQL languages that you could actually use variables and use code, and like you could actually break this up into multiple sort of sub tables and then operate on those tables individually as like looping over. Like you could actually use some sort of, I guess, simple programmatic logic, I guess, but you can't do that in this context. You're so constrained. It's like who knows? Yeah. All right, we have to look at partitioning, I think. Let's start with that. There's so many things that we probably just have to go learn what they do, how to use them, and maybe we could use them. All right. What's a value? We don't need these. We need a select. We need a excuse me. Oh, dude, I just not that interested in SQL. Just not that interested. All right. Somewhere around here is partitioning. It's interesting too because this isn't even touching like other databases like MongoDB or Elasticsearch or like the other. There's like loads of other databases. This is like just strictly SQL. Insert data definition. No, that's another thing too. Is like none of this stuff is ever like checked in questions and things. Like there's just one SQL statement. That's a one really hard SQL statement. It's like there's so many other things, creating tables and modifying tables, and creating table spaces and creating databases. All this stuff. I never even look at because it's like that's not what they test, so I don't even know. Operators. Alrighty. Full text search functions. Mecab full text parser plugin. I'm sad, dude. Sad. What am I looking for? Oh yeah, comments. I need to know that because I comment out my code so much when I'm. Oh, it's a pound symbol. Okay. All right. I was gonna say when I'm like trying to solve an SQL problem, I just like comment out so many pieces because I'm like try this, try that. Oh, it's funny. Okay. Oh, that's interesting. You could have it within a line. Oh, straight join. Oh, there we go. That's what I needed. I needed a straight join before. Oh, wait. MySQL specific code. Certain variants of C-style comments. Or code that includes SQL extensions but is portable by using comments in the following form. What? Select straight join column 1 from table 1, table 2. Oh. SQL server parses and executes the code within the comment as it would any other SQL statement. Other SQL servers should ignore the extensions. Oh, that's interesting. I didn't know that. I need a like SQL fiddle. Fidel. Or I should just install SQL on my computer. All right. So let's do that. Sample fiddle. Create table if not exists. Insert into table. Select inner join. All right. Borrow from Stack Overflow. Okay. Let's clear everything. All right. We want to create a table. All right. Build schema. Schema ready. Select from docs. All right. That's interesting. So let's try to build this from scratch, right? Because I should know how to actually just build an SQL table at least. So I don't know. We'll create table if not exists. Basic table. And we want to name it. So can we use, let's see, have an error. Let's do ID int. So what's interesting is it looks like these need to be strings. Okay. So they use backticks. Do you need one of these? So yeah, okay, let's go to create table. Let's take a look. This is how, like this is like when I get interview questions about SQL, like this is what it looks like. This is me on the other end. I'm just like, I don't know. I don't use that. I took an SQL class 8 years ago, a database class 8 years ago, and you know I used Elasticsearch at work and TSQL, which has the variables I was talking about before. It's just upsetting, man. It's just upsetting. All right, let's do data definition. Okay, create table. That's what we need. Create table. Let's go with that. Files created by create table. Create temporary table. Okay, create table if not exists, table name. Create definition, table options, partition options. Excuse me. And do we need... there we go. Yeah, the opening and closing... opening and closing parentheses. Okay, so you do need those. And you have table options, partition options, which is over here. Okay. So what does create definition look like? Column name, column definition. All right, what's a column name look like? Column definition. What does that look like? And there's a bunch of or things you may or may not need or want. Data type. What's a data type? See chapter 11, data types. Okay. 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 Numeric data types. Integer. Int. Alright. So why doesn't this work? Can we just say ID int? Basic table. Why do we need backticks? Like, what is wrong with this? What is wrong with my table? Why, okay. Let's go to our data types. Okay. Tiny int, small int, medium int. Oh, that's interesting. Big int. Where, like, this would be just maddening, I would say. Trying to... Table name, okay. Table name can be specified as dbname.tablename to create the table in a specific database. This works regardless of whether it is a default database. Assuming that the database exists, use quoted identifiers, quote the database and table names separately. For example, write mydb, mytable, not mydb, mytable. Rules for permissible table names. Schema object names. If not exist, prevents an error if the table exists. No verification that the existing table has a structure identical to the one indicated by create table. Okay. Temporary tables. Use temporary keyword when creating a table. Temporary table is visible only within the current session. Is dropped automatically when the session is closed. Okay. Table cloning and copying. There's a like. There's an as. Ignore, replace, data type. I'm going to go into the data type in a moment. Can we have like an example here? So create table T, C, character set collate. Excuse me. Represents the data type in a column definition. For a full description of syntax available for specifying column data types, as well as information about the properties of each type, chapter 11 data types. All right, so where is syntax? Bit, tiny int, bool, boolean, tiny int 1, small int m, medium int m, unsigned 0 fill. So unsigned range. So I don't know what this m is supposed to be. What is the m there? What is the deal? Why is there an m? So you need to specify some m there. Like, yeah, this is the kind of stuff that's like, it's not it's not a logical thing, it's like a syntactical thing. Like, you just don't know how to specify an integer in the in the database. Like, you just don't know. Why would you know that? Why would you know that it needs to have a number next to it? How you wouldn't know that? Unless you tinker with SQL databases regularly, which I don't. I tinkered with an Elasticsearch database for the most part. Yeah, it's just gonna be like an hour of me complaining about SQL and MySQL. Alrighty. What does the M stand for? Integer data types. M indicates the maximum display width. The maximum display width is 255. Display width is unrelated to the range of values that a type can store, as described in section 11.1.6, numeric type attributes. For floating point and fixed data point data types, M is the total number of digits that can be stored. Oh. As of MySQL 8, the display width attribute is deprecated for integer data types. You should expect support for it to be removed in a future version of MySQL. Okay. Alright, that's obnoxious. It's deprecated, alright. So what does that mean? So, what MySQL version? Oh, we're not version 8, we're 5. Okay. That explains things. It's like, why? That's so painful. Because that's the other thing too. I used a version of, I want to say it was TSQL, where I didn't have to do that with the M. So that's super confusing. Dude, that's obnoxious. That's so annoying. So that's the error. That's the error. So I just don't have a display width. Let's make it 255. Whatever. That's not the error. There's some other error. A greater error. Can I just get rid of this? What? How come this doesn't get commented out? It's a comma. I mean, it's a comment. What? Multi-line comment in SQL? Okay. Learning that too now. This is upsetting. So upsetting. It's like you just feel so dumb. It's like I don't know the syntax because I don't use it. Who uses this? Who actually uses SQL? I'm joking. I guess some people do. I got a lot of people do. A lot of people do. It's not fair at all to say who uses this. Okay. All right. What is it doing? Something else here that's important. What is it like? Oh, comments. Yeah. So we need the. Yeah, we could close these. We don't need to have all these open. Oh no! Oh, not that one. That one we want to keep open. All right. Well, we lost our. Hold on. What is? So my question here is, yeah, I keep getting this error. Why that error though? Because shouldn't this comment be, all right, we're looking for the language structure, right? So there's language structure. Okay. Comments. Why not? 3 comments. 1, 2. Okay, from sequence to the following sequence, C programming language labels a comment extend or multiple lines. All the comment style. So for some reason, this multiple line comment is not working, right? That's bizarre. I don't know why that would be. It's not stored on the server. Comment programs, comments are not retained in the program body. Not sure what that means exactly. Another variant. Use specifier optimizer hints. Hint comments include a plus character following this opening sequence. Short form MySQL commands such as \c within multiple line comments is not supported. Do work within single line version comments. As do the optimizer hint comments, which are stored in object definitions. There's a concern that optimizer hint comments may be stored in object definitions, so that dump files, when reloaded with MySQL, would result in execution of such commands. Either invoke MySQL with the binary mode option or use a reload client other than. I don't know what they're talking about, quite frankly. I don't know what they're talking about here. Why can I not just comment out these other commands? Why is this giving me such a hard time? If I remove them, it works, right? Also, what about, was I wrong about this? Does this matter? Oh, okay. All right. So what part of this is causing issues? Like, is it this part? How about this part? How about this? Ah. That's interesting. So it's this. It's causing issues. This insert into. Apparently this insert into makes it past the oh. Whoa. What? Huh. Now, I don't know if that's just a bug in SQL 5.6 bug. So that's baffling, right? Just absolutely baffling. But I guess the, alright, so my brain is melting. But, so, wow. Oh, gotta just sit down for a moment here. Of course. This is why. So I can't have nice things. Oh, okay. I'm pretty sure I ran into this problem before. And I just didn't have the patience. I was like, I don't know why your fiddle is broken, but it's driving me insane, and I'm leaving. I'm just not gonna bother. I'm trying to learn SQL. Excuse me. Now my question is this: is it the I don't know. Maybe it's just the like I'm wondering if it's just the the web page, the way that's parsing the code is wrong, and then trying to send the code to an SQL SQL program, or if this is like, I'm wondering if there's an intermediate step in between, or if there's genuinely an error on the SQL programs on SQL 5.6. I think it's the fiddle. I think it's the fiddle's bugged. Yeah, I remember that happened before, and I was like, I quit. I'm not gonna mess with this. Whatever. Learn SQL. Learn SQL another way. Instead of messing around with tables and whatnot. All right, so we can create a table, and now I want to insert into this table, basic table. We're gonna insert values. Have an ID, we'll have a name varchar, right? I'll make these not null. just upsetting. I don't know, man. It's hard. John, Mark. Oh no, we'll do Mark, Luke, John. Wait, Mark. I think it's Matthew or Mark. I think it's Matthew. Matthew. Mark. Luke. And John. I don't remember Luke is the last one, or it's John's the last one. Four Gospels. Matthew, Mark, Luke, John. 4 Gospels. Okay. Praise God. Alright. Error in my syntax. Varchar not null. So I think variable characters you need to specify. So I don't think it was my issue. I don't think it was me that had the problem there with the comments. I think it was genuinely I think there's a problem with my comments. I think it was genuinely turn this down a little bit. I think it was genuinely the fiddle had some issue parsing the comments. I think that's what it was. It's painful. It's painful. Alright, we're looking for numeric data types, string data types, okay. Character and varchar types, let's go. Whew. Character and varchar types are similar but differ in the way they're stored and retrieved. They also differ in maximum length and in whether trailing spaces are retained. Okay, I'm not sure what they mean by trailing spaces. It just means spaces that are to the right of your code, yeah, or just extra white space to the right. Character and varchar types are declared with a length that indicates the maximum number of characters you want to store. For example, character 30 can hold 30 characters. Length of a character column is fixed to the length that you declare when you create the table. The length can be any value from 0 to 55. When character values are stored, they write padded with spaces to the specified length. Oh, interesting. Okay. Character values are retrieved. Trailing white spaces are removed unless the pad character to full length SQL mode is enabled. Oh, I see. So when you store it, all of the extra space is filled with spaces, and when you remove it, you remove all those trailing spaces. Values of varchar columns are variable length strings. The length can be specified as a value from 0 to 65535. Okay. The effective maximum length of varchar is subject to the maximum row size, which is shared among all columns, and the character set used. Oh, now you can run into issues doing this, right? Because if you have, oh, that's tricky. So part of the problem here is the maximum row size is shared among all of the columns. So if you varchar the whole column, you can run into some issues. Whoops. Shared among all columns. And the character set used, see 8.4.7, limits on table column count row size. So varchar is larger than char. Okay, or char. Varchar and char. Call them chars. Contrast to char, varchar values are stored as a 1 byte or 2 byte length prefix plus data. Length prefix indicates the number of bytes in the value. A column uses 1 length byte if values require no more than 255 bytes. 2 length bytes if values may require more than 255 bytes. Okay. Strict SQL mode is not enabled, and you assign a value to a char or varchar of column that exceeds the column's maximum length. Value is truncated to fit, and a warning is generated. Truncation of non-spaced characters, you can cause an error to occur rather than a warning, and suppress insertion of the value by using strict SQL mode. Okay, interesting. Varchar columns, trailing spaces in excess of the column length are truncated prior to insertion, and a warning is generated regardless of the SQL mode in use. For char columns, truncation of excess trailing space from inserted values is performed silently regardless of the SQL mode. Varchar values are not padded when they are stored. Trailing space are retained when values are stored and retrieved in conformance to the standard SQL. Okay, so varchar and char are different from each other. Excess of the column length are truncated. Okay. Truncation of excess silently. So probably varchar is better to use than char, because you might want to have spaces in your names, like trailing spaces. Uses 1 more byte for varchar, but I think it's worth it. Values shown as stored in the last row of the table apply only when not using strict SQL mode. If strict mode is enabled, values that exceed the column length are not stored, and an error results. InnoDB encodes fixed length fields greater than or equal to 768 bytes length as variable length fields, which can be stored off page. For example, a char 255 column can exceed those bytes if the maximum byte length the character set is greater than 3, as it is with UTF-8 and v4. Okay. Understood. If a given value is stored into the char and varchar columns, the values retrieved from the columns are not always the same because trailing spaces are removed from char columns upon retrieval. The following example illustrates this difference. Which is what I was just describing that. It's like, oh, it'll be different based on the, which I think is better to use varchar in that case, because it's just kind of disconcerting to have that happen to you. Like, I don't know why you'd want to have trailing space in your database, but maybe you do. Who knows? Values in char, varchar, and text columns are sorted and compared according to the character set collation assigned to the column. Well, what is string data type? I guess there's blob and text. What about those two? To determine the pad attribute for a collation, use the information schema collations table, which has a pad attribute column. Not sure what that's referring to. Collations have a pad attribute of pad space other than Unicode collations based on UCA 9.0.0 and higher, which have a pad attribute of no pad. For non-binary strings, char, varchar, and text values, the string collation pad attribute determines treatment in comparisons of trailing spaces at the end of strings. How long have we been doing this for? 40 minutes now. No pad collations treat trailing spaces as significant in comparisons. Like any other character, pad space collations treat trailing spaces as insignificant in comparisons. Strings are compared without regard to trailing spaces. See trailing space handling and comparisons. The SQL server SQL mode has no effect on comparison behavior with respect to trailing spaces. For those cases where trailing pad characters are stripped or comparisons ignore them, if a column has an index that requires unique values, inserting to the column values that differ only in the number of trailing pad character results in a duplicate key error. For example, if a table contains A, an attempt to restore A space causes a duplicate key error. Okay, yeah, that's what we'd expect. More information about MySQL character sets and collations. See Chapter 10 for additional information about storage requirements. See data type storage requirements. I don't know what they mean by collation. What's collation? Maybe we should look at that. Excuse me. Don't know what InnoDB is. Oh yeah, we want to know. Okay. Blob and text types. A blob is a binary large object that can hold a variable amount of data. The 4 blob types are tiny blob, blob, medium blob, and long blob. Bob Loblaw is Loblog. Have you check it out? Seen it? It's differ only in the maximum length of the values they can hold. The 4 text types are tiny text, text, medium text, and long text. These correspond to the 4 blob types and have the same maximum lengths and storage requirements. Blob values are treated as binary strings to byte strings. They have the binary character set, and collation and comparison and sorting are based on the numeric values of the bytes and column values. Text values are treated as non-binary strings. Character strings, they have a character set other than binary, and values are sorted and compared based on the collation of the character set. Okay, what do you mean by collation? I need to know what they mean. I want to know. Can you show me? MySQL includes character set support that enables you to store data using a variety of character sets and perform comparisons according to a variety of collations. The default MySQL server character set and collation are UTF-8 MB8 and UTF-8 MB40900 AICI. Of course. I actually know what UTF-8 MB4 vaguely is, but this one is like, I don't know, it's probably some version of it, I guess. But you can specify character sets at the server, database, table, column, and string literal levels. Sweet. This chapter discusses the following topics. What are character sets and collations? Yeah, thank you. I would like to know, what do you mean by collation? I don't know what that word means. Why would you assume I know what that word means? I don't know. I guess what other word would you use? Maybe it's better to assume that. Yeah, okay, fair. Fine. Multiple level default system for character set assignments. Multiple level default system for character set assignment. I don't know what that means. Syntax for specifying character sets and collations. Great. Affected functions and operations. Unicode support. The character sets and collations that are available with notes. Selecting the language for error messages. Selecting the locale for day and month names. Character set issues affect not only data storage, but also communication between client programs and the MySQL server. Yeah, big time. If you want the client program to communicate with the server using a character set different from the default, you'll need to indicate which one. For example, to use the UTF-8 Unicode character sets, issue this statement after connecting to the server. Set names UTF-8. More information about configuring character sets for application use and character set related issues in client-server communication. See Section 10.5, configuring application character sets and collation. Section 10.4. Connection character sets and collations. All right, we want to know what they mean by character sets and collations. Character sets and collations in general. A character set is a set of symbols and encodings. A collation is a set of rules for comparing characters in a character set. Let's make the distinction clear with an example of an imaginary character set. Suppose that we have an alphabet with 4 letters, A, B, A, B. We give each letter a number, A equals 0, B equals 1, A equals 2, B equals 3. The letter A is a symbol, the number 0 is the encoding for A, and the combination of all 4 letters and their encodings is a character set. Suppose that we want to compare 2 strings values A and B. The simplest way to do this is to look at the encodings, 0 for A and 1 for B. Because 0 is less than 1, we say A is less than B. Then what we've just done is apply a collation to our character set. Collation is a set of rules, only one rule in this case, compare the encodings. Call this simple of all possible collations a binary collation. But what if we want to say that the lowercase and uppercase letters are equivalent? Then we would have at least 2 rules. Treat the lowercase letters A and B as equivalent to A and B, and then compare the encodings. Call this a case-insensitive collation. It is a little more complex than a binary collation. In real life, most character sets have many characters, not just A and B, but whole alphabets, sometimes multiple alphabets, or Eastern writing systems with thousands of characters, along with many. Programming is so much easier for the Westerners. They have an advantage. Joking. Thousands of characters along with many special symbols and punctuation marks. Also in real life, most collations have many rules, but not just. Also in real life, most collations have many rules, not just for whether to distinguish a letter case, but also for whether to distinguish accents. An accent is a mark attached to a character, as in German. Oh yes, the umlauts. The umlauts. Accents in German. Accent is a mark attached to a character as in German, and for multiple character mappings such as the rule O umlaut equals OE in one of the two German collations. Oh yeah. That's usually what you do with umlauts, is you add an E next to the vowel. Umlaut. Sehr gut. Wunderbar. Wunderbar. Actually, I think wonderful is a name reserved for Christ, and so awesome is a name reserved for God. Anyway, or is an expression reserved for God. MySQL can do these things for you. Store strings using a variety of character sets. Compare strings using a variety of collations. Mix strings with different character sets or collations in the same server, the same database, or even the same table. Enable specification of character set and collation at any level. To use these features effectively, you must know what character sets and collations are available, how to change the defaults, and how they affect the behavior of string operators and functions. To use these features effectively, you must know what character sets and collations are available, how to change the defaults, and how they affect the behavior of string operators and functions. Okay, fair enough. I get it. I get it. So collation is how you compare the strings to each other, and the character set is how you interpret the bits or the bytes in your string. Relate them back to the characters themselves. I think I understand what they're getting at here. Character sets and collations in MySQL. Character set repertoire, UTF-8 for metadata. Oh, there's so much to read. I don't want to spend all this time reading. I just don't want to. Okay. MySQL Server supports multiple character sets, including several Unicode character sets. To display the available character sets, use the information schema character sets table or the show character set statement. A partial listing follows. For more complete information, see section 1010, supported character sets and collations. Show character set. Character set description, default collation, max length. So Big 5, binary, Latin 1, UCS2, UTF-8 MB4, MB3, UTF-8 MB4. Description, Big 5 traditional Chinese, binary pseudo character set. CP 122.25.2, 125 TCP, 1252 West European, UCS2 Unicode, UTF-8 Unicode, UTF-8 Unicode, Big 5's Chinese CI, default collation binary, Latin 1 Swedish CI, UCS2 General CI, UTF-8 General CI, UTF-8 MB8, MB4 0900 AI CI. Oh, I see. So I think the MB3 uses a different collation. What is MB3 and MB4? What is that? Okay, not looking for a galaxy. No. Alright, fine, we'll go Stack Overflow. Difference, I already know that ASCII, UTF-8, UTF-16, 32 are codings, MB4, MB3, variable length encoding, UTF-8, this means that storing one code point requires 1 to 4 bytes. UTF-8, alias of UTF-8 MB3 only stores a maximum of 3 bytes per code point. Oh, maximum byte 3. Got it. Character sets cannot store all the code points. Supports this range. Okay. One-year column to support storing characters laying outside the BMP and usually want to, such as emoji. Emojis. Okay. All right. I don't know. I don't know why I'm doing that. Saying that. Just UTF-8 MB4. See also, what are the most common non-BMP Unicode characters in actual use? What are the most common non-BMP Unicode characters in actual use? UTF-8 MB4 character set. It's useful because nowadays we need support for storing all language characters. Okay, got it. I don't know. There's an MB something with UTF-8. There's something here. I thought, maybe I'm wrong, I thought there was something I saw a while back. I'm looking for oh, UTF-1. Oh, that's interesting. Oh, I don't know. I thought I saw MB3, MB4 related to something else, so I guess that's just for SQL. That seems to be the only on the question on Stack Overflow only seems to be related to SQL. Okay, interesting. I don't know what this 900 AI CI stands for, or what general CI is. I don't know. I guess CI is just collation in general. Okay. And there's UTF-16, UTF-32. Whoa. That's interesting. Excuse me. Different collations and character sets. Excuse me. So there's a bunch going on here. I don't know if we need to know all this stuff, but I just want to know what they're referring to when they say collation. So I think I get it. All right, that's fine. That's probably enough for us now. String data, char varchar, binary var binary blob text enum set. Change a string column to a type different from that given in a create table or alter table statement. See section 13, silent column specification changes for definitions of character string columns. For definitions of character string columns, char varchar, and the text types, MySQL interprets length specifications and character units. For definitions of binary string columns, binary, var binary, and the blob types, MySQL interprets length specifications in byte units. Column definitions for character string data types. My brain. Sorry, I'm thinking about something else I'm trying to read, which happens from time to time. Just distracted. Sorry. Some cases, MySQL may change a string column to a type different from that given in a create table or alter table statement. Silent column specification changes. Whoa. For definitions of character string columns, char, varchar, and the text types, MySQL interprets length specifications and character units. For definitions of binary string columns, binary, var binary, and blob types, MySQL interprets length specifications in byte units. Okay. All right. Column definitions for character string data types, char, varchar, and the text types, enum set, and any synonyms. closing parentheses, missing an opening parentheses here. Can specify the column character set and collation. Okay, neat. Char, varchar, text, enum, and set. All right. Character set specifies the character set. If desired, a collation with the character set can be specified with the collate attribute along with any other attributes, for example. All right, so I understand what they mean now. Did not know what they're talking about. Now I get it. This table definition creates a column named C1 that has a character set of UTF-8 with a default collation for that character set, and a column named C2 that has a character set of Latin 1 and a case-sensitive CS collation. Case-insensitive, case-sensitive. That's what CS and CI stand for. Got it. Got it. Understood. Understood. Verstand. The rules for assigning the character set and collation when either or both of character set and the collate attribute are missing are described in section 10.3.5, column character set and collation. The rules for assigning the character set and the collation. The rules for assigning the character set and collation when either or both of character set and collate attribute are missing. When either or both are missing, are described in section 10.3.5, column character set and collation. So there's defaults when you don't specify them. Okay, that's fine. Character set is a synonym for character set. Char set, character set. Car, varchar. I don't know, CHR-AR for car is so weird. Character, care, maybe care and varchar, call them chars. Let's go with that. Characters, call them characters. I didn't make the language, man. Right. I think char, varchar, and then when it's a character, it's character. And it's a car and varchar. Oh, it's so confusing. I didn't make the language, man. That's great. Okay. Specifying the character set binary attribute for a character string data type causes the column to be created as the corresponding binary string data type. Char becomes binary, varchar becomes var binary, and text becomes blob. Whoa! Whoa! So as you can convert these to their binary forms or their character forms. Oh, I see. Okay. Enum and set data types, this does not occur. They are created as declared. Suppose that you specify a table using this definition. So enum, character set binary. Resulting table has this definition. Enum is still the same, but you convert varchar to var binary and text to blob. Binary attribute is a non-standard MySQL extension that is shorthand for specifying the binary collation with the column character set or of the table default character set if no column character set is specified. In this case, comparison and sorting are based on numeric character code values. Suppose that you specify a table using this definition. This is a non-standard extension. Okay. Latin binary, text binary, UTF-8 MB4. Table has this definition. Character set Latin, collate Latin 1 bin, UTF-8 MB4, collate UTF-8 MB4 bin, UTF-8 MB4. Okay, I see. All right. I don't know if we need to keep reading this. This is like probably enough to get a better sense of what's going on with like when you want to specify table values. Now, what is a set and an enum? Those are the only things I don't know what those are. Also text and blobs and things. Maximum length of 4 gigabytes. Whoa. Huh. Okay. No kidding. Just a blob or a 4 gigabytes of data for this is wait 1,000 2,000 1,000 1 million 4 billion. So a billion is a gigabyte, a million is a megabyte. This is 1,000 16 megabytes. Okay, gotcha. So medium text, medium blob. Megabytes of data, be kilobytes of data. Okay, I get it. I get it. So you have blobs and you can have text. Alright, enums and sets. Enumeration, a string object that can have only one value chosen from the list of values. Null or the special error value. Enum values are represented internally as integers. Enum column can have a maximum of 65,535 distinct elements. The maximum supported length of an individual enum element is less than or equal to 255, and m by w is 1020, where m is the element literal length and w is the number of bytes required for the maximum length character in the character set. Okay, so each element can only have 255 characters, and if the width is 4, then you have to have these two limits on m and w set. Yeah, well, the width could be, I guess in theory, it could be more than 4, and then m has to be smaller than 255. A string object that can have 0 or more values, each of which must be chosen from the list of values. Set values represented internally as integers. A set column can have a maximum of 64 distinct members. Maximum supported length of individual set element is similar to the enum. M is the element literal length, and W is the number of bytes required for the maximum length character in the character set. So enums are a little bit larger than sets, but they're roughly equivalent in SQL. Okay, that's good to know. That's useful. Alrighty. Wow. Okay. Great. So let's get back to our basic table. Have an error. Okay, let's do insertions. Let's take a look. So our var card does need to have a width though. We're gonna say 255. Okay, is it the insertion? Is that the problem? Have an error. Can you have not null for var card? Data types. Where was this is what I'm looking for. No, not data requirements. Actually, I was just looking at it. The syntax. This is the one I'm looking for, I think. Yeah, I want the syntax. So, where is varchar? Varchar, var binary, varchar. M. Okay. So where's the issue with this? Let me just make sure this is not the problem. Can you say not null for varchar? Maybe that's the problem? No, you can't say not null. That's why. Can't be not null. Hello. Are we live? Do we die? No? I don't know what's going on now. It's suddenly having some issues, this website. What is happening? Why? Why is this such a problem? What's going on, man? Oh no. I broke it. I broke it. Alright, no problem. But what if I just say varchar? Schema ready. Alright, two of them together. Error. Okay. So I put a comma in there? There we go. Alright. Okay, that's good. Somehow broke the page before, but fair enough. Hey, it worked. Sweet. Hey. We have our table. We have Matthew, Mark, Luke, and John. All right, there we go. Now we can do things. Hey ho. Let's see what our maybe I just need one of those. There we go. Okay. Hey! Huzzah! All right, now we can properly test. Now, yeah, I feel like I don't know. I usually do kind of keep my voice low. I yell every now and then and talk very loudly, and then I guess this red part breaks and it's uncomfortable if people listen. I don't really know, man. I don't know. I think I talk too loudly. Had the volume up too high or something, who knows. Lower it a bit. Huzzah! Ho ho! Hey hey! We did it! I just want to go play a game of Minesweeper and rest on my success. Finally, now I can tinker with SQL online without feeling like I don't know anything. Yeah. Oh boy. It's like it's a little ridiculous. I don't know, man. I don't know. No excuse. Okay. Huh. Running in the 90s. Oh no. Running in the 90s. Bum bum bum. Da 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 da. Ba ba da 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 da. Running in the 90s. Hmm. Uh-oh. 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 Mm-hmm. 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 Uh-oh. 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 I think that's all I got, man. Now we gotta guess. There's one here. 1, 2, 3, 4. Only one here. There's one there. Can't be one there. Can't be one there. Don't have to guess yet. Not yet. Not yet. I think half the time it's like, just depends on how patient I am. How well I do in this game. How patient I'm feeling that day. 1, 2, 3, 4. Yeah. Feeling particularly patient, then I do better. Not feeling patient at all, then I just fail. Running in the 90s. Oh, okay. Alright, so there's one there. Can't be one there. There's one there. Just want to take a break for a moment. So there's one here, and one here, one here. It's probably here. No, wrong. Alright, no guessing. No guessing allowed. Running in the 90s. Oops, didn't mean to do that. Okay. Whoa. That was revealing. Running in the 90s. Okay. How are we doing on time? I should go back to what I was doing, studying SQL. Just want to take a break, man. Just want a break. Oh no! Oh. Do 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 do. Running in the 90s. Oh no! Oh, I did that wrong. Did that totally wrong. Oh no. Wrong, wrong, wrong. It's all wrong. Alright. There's gotta be a mine somewhere here. Yeah, okay. Running in the 90s. Boom, 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 no, no, no. Okay. How are we doing? So one here. Must be one there. One here. One, oh. There's two. Oh, okay. There's one here. There's nothing there. 1, 2, 3, 4. Okay. Oh, that's not good. Uh-oh. Okay. Okay, I'll have to look at that one in a minute. That one I'll probably have to guess, I think. So we have the left, oh, there we go. That's one there. It's one here, it's one here, it's two here. It's one here. Could be here or here. Probably not there. There we go. That was a guess. Probably should have done that. Probably should have done that. Two mines somewhere here. There's gonna be one there. There can only be at most one here, so there's gotta be a mine here. I don't know. It's kind of hard. Well, there's a mine here. There's a mine here. There's one here. There's one here. There's one here. One, one, one. And there's only one here, which means if there's one here, and one here, but only one here, then it could either be this one, or this one, and this one. Alright, I don't know. Probably should have done what I did. Running in the 90s. Alrighty. Oh no! Oh, messed that up. Oh no! I did it again. No! No! Um. I don't know. I don't know, man. I don't know. Some of these maybe I could know, but I haven't worked out the, oh no, oh boy. That's bad. Some of these I probably could know, but I just haven't worked out like what the possibilities are. Gone through all the logical kind of pieces. Oh no. Running in the 90s. Alright, we should probably get back to what I was doing before. Oh no! Oh, I did it again. Oh, what a mistake. What a mistake. Okay. How are we doing on time? Yeah, I should get back to what I was doing before. I don't know. I kind of want to try to get a win here. I don't know, man. I don't know. No obvious thing. Oh, here we go. Oh, that helps. Really, it's just a matter of patience. I think so. Oh no! Oh, I almost did it. Oh, it was so close. I almost did it again. Alrighty. So, yeah, I guess that one. I don't know. Sometimes I go for a guess. It's not the best, but I do like to do that from time to time. Okay. All right. We're getting closer. So, problem. I don't think I have a way in. Let's see. This one is one here. That's obviously, there's only one mine there. 1, 2, 3. It's 2 here. It's 1 here. 1 here. Maybe come back to that one. This, mine there. No, mine there. 1, 2, there's 3 here. There's only 2 spots that don't have one. Here there's 1. Here, no, excuse me, there's 2 here, 2 here, and 2 here. Wondering if that has a thing. I don't think so. This is 1 here, 1 here, 1 here, and 1 here. So who knows? I could just guess, but that's probably a bad idea. Let's see. There's at least 1 over here, right? There could be 2 here. So the problem is if there's 1 here, then there's 1 here with certainty. But there could be 2 here. Like, it could be right here, these 2. It could be these 2, or 1 and 1 here and 1 there. But if there's 1 here and 1 there, then this can't have 2. So you can't have 1 here and 1 there. Maybe you could have 1 here and 1 here and 1 here and 1 here. You could do that. It could be 2, 2, and just 1. No, I don't know. Just guessing. That was probably a bad spot to guess on because of the odds randomly choosing. Yeah, that's probably not the best call. Sometimes it's a little bit easier. Sometimes it's a little bit easier. Oh, there's a mine there. Oh no! Oh no! No! I made a mistake. Misclicked. Clicked the wrong one. Oh, okay. Oh no! Okay. I don't know what to do in this one. Okay. Oh, that works. Well, that helps. Not sure if I should have done that, but okay. So one there, one there. Oh, there's two here. 1, 2, 3. There we go. That helps. Hey. Oh, careful. Careful. So there's two here. There's not one there. 1, 2. There's one here. There we go. Solid guesses. Solid guesses. I think that's this way. Okay. Well, this is challenging. I don't know. I have to throw in some guesses. It's here. It's one here. It's one here. It's one there. It's one here. It's one here. It's 4 here. Who knows? One there. One in this whole thing. Oh no. So maybe I have a good chance of guessing there. Oh no. Did that wrong. Uh-huh. Oof. How are we doing? Uh-huh. Oh, that was so close. I almost clicked the wrong one. It was close. I almost did it. Oh no. Phew. Wow. Wow. Oh boy. No kidding. Whoo-wee. All right. Okay. All right, making some progress here. Okay, somewhat stuck. Might be stuck. Not quite. Not totally. Not completely stuck. Okay. All right, how are we doing here? All right. We don't know about this one. That's kind of locked up. This one, maybe. We know there's a mine here. Like, there's got to be either 1, 1 or 1, 1. So there's a 1 here. So there's 1 here, 1 here. Oh. Okay. Oh no. Shoot. Um. Huh. Hmm. Oh no. Oh. Discounted. Okay. Whew. Uh-oh. I think we may have gotten stuck on the left side there. Alrighty. Okay. That's good. So now the question is, a couple lines here. I don't know. I don't know. Sometimes not sure. Oh no. Oh. Hmm. Oh no. Oh. Oh. Oh no. Oh, that was bad too. Okay. Oh no. It's making so many mistakes so quickly. Oh, that was close. Whew. Hmm. Hmm. Alrighty, so here we are. I gotta start guessing, I think. I don't see any obvious things. Yeah. That worked out. Does not always work out, but that worked out. Not out of the woods yet, though. Okay, there's one here. Says no mine there. Must be one there. Okay, there's 3 here. 2. There we go. That's good. Oof, I was lucky. I was lucky. I've got 9 left. 2 here. 1 here. 1 here. 1 here. There's a bunch. Ooh. 2, 3, 4, 5, 6. And there's 7, 8, 9 somewhere in here. I think. Oh man. Very likely one of these two. I'm gonna go with that. Okay, that works. Oh man, there's so many mines just crammed in here. What do I do? I don't know. Suffer. That's what you do. I know there's one that's not there because there's 1 here and 1 here, right? So there's 1, 2, 3 has to be, yeah, has to be open. Oh man, all right. So there's 1, 2, and there's 1 plus 3. 1 plus 3 is 4. There's 4 here. 5, 6. So this should be open. There we go. All right. Excuse me. All right, I got 4 mines. So there's 3 here and 1 there. Can't be 1 there. Okay. That's good. Hey, we got there. Now, instead of studying SQL, I'm going to just play another game of Minesweeper. Yeah, I could. Why not? I probably should. That was a bad idea. Definitely should have done that. Yeah, just got myself in trouble. Okay. Okay. Well, if there's two here, means that this one and this one is open. Hmm. Oh no! Oh, I almost clicked it. I almost clicked it. Easy bud, easy bud. Don't do that. Oh no! Oh, that was so close. Whew. Almost clicked. Hmm. Okay. Hmm. Hmm. I don't know. Oh no! Oh. Almost lost. Oh, that would be close. Alright. I think we got that so far. That's good. So there's one here. So that means there's not one there. 1, 2. Hmm. Actually, if I answered this part, I might have something. There's one here. There's one here. There's one here. Oh. Oh no. Hmm. 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 Oh, look at that. There we go. Nice. Hmm. Um. I think I got stuck again. No, not yet. Almost. Yeah. Okay, baby. Yeah. Maybe. Yes. All right. So it's interesting. So there's a mine. One of these four is a mine. Here, there's probably more than one. So it could be here. If it's here, there's a mine here. So it could be here. Could be here. Oh, no, it's over here. All right. Let's try to figure out a way to narrow it down where the mine is. Yeah. It's actually kind of hoping that the spot I was clicking on would be mostly empty space. And so we get more to work with. Sometimes you could do that. Oh, we did it. Hey, that was under 3 minutes, right? Yeah, 60 by 3 is 180. Whoa. Whoa. Wasn't expecting that. Sweet. Every now and then you get lucky. Every now and then you get lucky. Okay, so what we want to do is we want to manipulate our table. So the question that I had before that I was working on, it's not the same as this one, but if you have like multiple tables and you want to join on your tables, so like let's say we had 2 tables with IDs. Let's say, so you could have we want basic table. We're going to say employee. Like this is a typical thing, like employee. And then we have another one, which is department. Departments, or just department, right? So we're going to have 2 things that are department. We want an ID and a name. Call it dep name, department name. All right, so employees, you have IDs, you have names, you have manager ID, now which could be null. You have department ID, which could be null, and manager ID, department ID, name ID, and then salary. All right. So now we have Mark, Matthew, Luke, and John. Matthew's manager is Luke. Oh, I don't know if I should do that. I don't want to make managers apostles of managers of each other. All right, we use different names. Say Mike, Martin, Josephus, and Milo. There you go. Mike, Martin, Milo, and Josephus. Okay. Okay. All right. Okay. Manager ID 3. Department null. And salary 3,000. Null, 200,000. Make these guys wealthy. All right. They get paid well. Okay. These employees, they do well. All right. They do well. Josephus' manager is Milo, and his department is 1, and he makes pretty good money. Does okay. And Milo's department is a different department, has no manager. It's department 2, and he does okay as well. All right. Let's have employees. Have some employees. I have departments. Insert into our department table. We're going to say, values. We're going to have 2 departments. One, IT. Another is sales. We'll do it that way. All right. What do we get if we do this? Table, basic table doesn't exist. Okay. So we have our employee. We have department. All right, sweet. So what we want to do is I want to take a join on the IDs, right? Department and employees. So employee, we want, let's go something like this. It's going to be order by salary, right? Descending, limit 3, and then what we can do is make this a subquery as a, select from the subquery, and we're going to order by salary, or no, actually, we can just limit 1. Okay. So let's go descending. Now we can reverse again, order by salary ascending. And limit 1. Now what happens if we comment these parts out? I'm using my glasses today. Using my glasses today. I want the third largest salary. Yeah. So we can, right, so we'll get Milo if we go the other way around, we should get Milo. Martin. Oh. Well, that's interesting. Oh, these are unique salaries. We get Martin if we. Can we do this? There's a way to do this. We could use an aggregate, I think. Row number as row. We can say as A, where row, or is this R? Where R equals 3. Okay. Okay. So we want to get the right amount even with duplicates, I guess. Row number. There's a row number. Window function descriptions. Yeah, that's what we're looking for. We're looking this. There's aggregate functions. We're looking for window. So row number. Okay. Over as. Yeah. Row number. Okay. Over W as. I think you just say over as. You do something like this. I went through a whole thing here too the other day of dealing with aggregates. Yeah. Oh no. Over. Partition. Oh, it's over is the partition. Yeah. So you just say over as and continue. Yeah. Row number over as R from employee. And I don't think you can do. You select everything else other than row number. You can do. You could write these directly. It's ID. Come on, man. It's driving me crazy. I can't tell if it's just the comments or the code itself is wrong because the fiddle has issues. Alrighty. Can't just. Oh, I see. Row number doesn't have a. I'm losing my mind. Why? So row number doesn't have a. What's that called? Row number does not have a parameter or an argument. Excuse me. I wanna know. This is what I'm talking about with the syntax. Like it's so foreign to me that it just takes me forever to figure out how to do something really simple. Why is it not working? Can't I just take row number over as from? Do I need it? Is that why it's the syntax? Is it just because I need it? Alright, let's just try to take it easy for a moment here. Why doesn't this work? Alright, that works. So we try row number over as R. This doesn't work. Why? Syntax is wrong somehow. Row number. What is the national chair? Char. I don't know what that is. Oh, okay. national char set, national character set. Anyway, okay. So there's row number and overclause. Okay, assigns peers different row numbers. Assign peers the same values, rank or dense rank. For example, use the rank function. Overclause. Row number over W as. Excuse me. So it creates a window. You have from. Can you just have like ID? Select ID. Overclause. Can I not? Does it work? Does not work. Yeah, these are like really basic SQL syntax related things that I would just struggle with every time. I would just struggle. It would just take me forever to figure out. Excuse me, it would just take me forever to figure out. Would just take me forever to figure out how to use these functions. Excuse me. Fall asleep here. Alrighty. Excuse me. We actually don't need all those things. So it's just not working. It's just not working. I don't know why. And I would think I could also just do this too, by the way. Does SQL 5.6 not have windows? Is that it? That might be the problem. It just doesn't have. It's obnoxious. It doesn't have aggregate functions and window functions. Yeah, that would be really annoying. Excuse me. I have this uncomfortable feeling that that's the case. So where is this in the? This is 12. All right, let's try 12. It's 8, 9, 10. Oh, they don't exist, do they? Uh-oh. Functions and operators. Oh no, there they are. Okay, aggregate functions. There we go. Oh. Window functions. Right below aggregate functions are window functions. Ah, you don't have window functions in, you don't have row number in 5.6. Okay. Oh, there you go. I don't know if InnoDB is the same thing as MySQL DB. The database itself is InnoDB. Oh boy. Oh. Yeah, okay. So the reason why I can't figure out how to use the syntax is because it's it's not supported. There are no window functions in 5.6. Oh, great. Ha. Dude, that's upsetting. How are you supposed to do this without that? I don't know. I don't know. Like which okay, here's the question. Which excuse me, which employee are you supposed to select that they're the same salaries? Oh, I don't know. I guess you could do it this way. Select from employee where order by first by salary, second by ID, limit 3. How about that? Ba-na-na-na. There you go. And then now you can, you know, you could do is you could say order by salary and by ID. Then you can make that a subquery. And then say select from there from A, order by again salary. So this is descending salary but ascending ID. And now you want to order by ascending salary and ascending ID and limit 1. So that'll give you a unique result each time. It's actually an entirely different problem that I'm looking at right now, quite frankly. But there's a problem that I was working on earlier that I don't know the answer to. Okay, there we go. So you have Mike every time. And this would be ascending, not descending. Or Milo every time. Milo or Martin every time. Martin. Now I guess my question is, should it be Martin or Milo? Because I think you want the smaller ID, right? If you made this descending, you'll get Milo. There you go. Yeah, I see that. So that's how you could differentiate between the two. I think it should be ascending. I think you want the first with Yeah, first of 3. Okay. So that gives you it gives you specific employee. Now we want to join this as B. We're going to left join with department on ID. A.id equals B.id. Okay. Yeah, so this is really tricky. If the Oh, I got this wrong. I only had like 5 minutes to look at this before. The problem that I was working on, I literally had 10 minutes for the problem. But I think there's supposed to be a department ID. And yeah, so you'd want, I see. So you have a.department ID. So this is as B. This is the kind of thing you just wouldn't solve quickly. Unknown column, A department ID. That should be B actually. An on clause. There you go. Alright, so let's add a department from Milo. Build our schema, run our SQL, and we get department ID, left join department, department ID equals department ID. Okay. So Milo, we're going to put Milo in sales also. Oh, excuse me, the manager ID. No. Milo's in sales, right? ID, name, manager, department ID is 2. So actually there is a department that he is associated with. Doing a left join where we add, there's another ID. So that was really weird. The program I was using before, when I did a join, I didn't get the 2 IDs, which was really odd. I didn't know what was happening there. I was so confused. But again, I only had like a few minutes to look at it, so it may have just been like what I was doing. Department ID equals department.id. Okay, we get ID and we get department name. What is what does this do? IT sales. So why do we not get how come our department ID is null? What is going on there? You have ID, name, manager ID, department ID, salary. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. If I just take a look at employee. Oh, Martin. Oh, that's right. We're not getting Milo anymore. We're getting Martin now. Oh, I see. Martin doesn't have a... I'll just put Martin in sales. That's probably has something to do with why we're having issues. Okay. Well, that's really interesting. Yes, that was really weird before. When I was working with the other problem, the other editor, I didn't see the join wasn't working properly. Like it's supposed to basically just copy over the other rows. If you did b.id equals department.id, you actually end up with the same thing. But okay. So now we also want if there's a manager too. So we could do multiple. Okay. This is C, so A, B, C. This is obnoxious, man. So now C, we get the department name, and we get the left join with itself, which is employee table again, on, and it's going to be C.manager ID is going to be equal to, we do as employee as, yeah, we do employee, it's fine. Employee ID. There you go. How about that? Oh no. Duplicate column name ID. Okay, so oh no. Alright, let's do this first. Can we just... This just gets so confusing. There we go. Select from A, then order by limit, select this B, then we're gonna be left join with department. So this is B, left join with department on department ID, right? This is, oh, we have A, we have B, right? We can, all right, we got our left join. This, we can make this C, and left join again with something like this. Duplicate column name ID. Can we say like C dot, something like this? What about this? So somehow we're having issues with duplicate column IDs. Can we rename the names? column names. Yeah, I think I understand what's happening. It's because you're like copying the two. Oh, I see the problem. Oh, I see. Yeah. I get it. Oh, I see. Huh. It's like boo is foo bar, a dot star, bar twice. Oh, okay, that's annoying. So you do have to specify everything. Alright, anyway. Let's go to the 5.6 documentation because clearly it's all we have available to us. And unfortunately, if this is what is all the only thing that's available generally to the public, then this is all that's available for when you try to use like interviewing sites. When you interview with a company, you're gonna have the same deal. Okay, so alrighty. Select from left join department. Right. So the issue you run into actually is that you need to rename these names because you're gonna get this ID twice. The employee table and the department table. So what we can do is select ID, name, manager ID, department. We don't actually need the department ID anymore. Department name, salary, ID in the field list is ambiguous. And it's going to be b.id. Alright, so we just need to get rid of the other ID. And then now we can make this a subquery. And now we're no longer ambiguous. I can left join in employee on manager ID, employee ID. Okay. And we have the same list. And it's no longer BID. So yeah, BID is the same. It's no longer the manager ID. You're gonna have the manager name. So that's kind of tricky. Also, it's the. What if you did this? Okay. Well, it's not the manager's ID that you want. You want the left join employee as X, and we're going to say select b.id, b.name, b.department name, b.salary, and we're going to have x.name as manager name. Something like this. Column BID in field list. Oh, C. It's actually C. C ID, C name, C department name, C salary, and X name. Something like this. C dot department name. department, employee ID, and on clause. Also, I think this is just unknown column employee ID on clause. Oh, x.id. Hey, there you go. Okay, this is the question I was asked before. You could do this in 5 to 10 minutes, but you'd have to be just an animal when it comes to you'd have to be an animal when it comes to like how familiar you are with SQL, MySQL. Like, it's not bad at all. Like, I could definitely do this, but like I'd have to have so much practice. Not an animal, but you have to have a lot of practice. Which I just don't have that much practice. Like, that took way more than 5 minutes. You could do this in 5 minutes in theory, but in practice, probably take you more time than that. You would need to do what I just did here, do some practicing with SQL beforehand. So you have your ID, you have your name, department name, salary, manager name, right? And then someone else, if we modify the values now, so let's say we want who has 3, so 150, 200, 200, so 200, 200, so we could do like 250, and then 1, 2, 3, so whoever has 250 is 3. So we said, we already looked at Martin, let's make Josephus 250, right? And we'll see who, oh, uh-oh. 1, 2, 3, oh, that's wrong. Uh-oh, that's not correct. Oh, it's the top 3. No, so 200 is the one. Okay, my mistake. It's from the top. 3 from the top. Josephus, IT, Milo. Okay. Yeah, so this was basically one of the questions I had that they asked. And I thought about it and I was like, oh, it's not too hard, but I didn't get it. It's also not that efficient. It's like super inefficient. Well, it's not too bad, I guess. Yeah. You want to run through the department once and run through the employee. Yeah, it's sort of linear in the number of in the size of the tables. It's not too bad. It's definitely interesting though to do it this way, subqueries. Yeah, this is fine. I mean, this works. I don't know. I didn't think of this at the time. I was like, I couldn't do it in 5 minutes. I was like stuck on just trying to do this part, just to get the one employee and how do I order it and limit and sort and how do I specify the names and all this information. I don't know, for whatever reason I got hung up on it. SQL is always challenging, messing around with SQL. Yeah. So you could left join, rename. Also this whole thing, like nesting queries. As B department ID equals department ID. Yeah, I think I definitely could have done this better. I definitely could have done this on the quiz, but again, 5 minutes, 10 minutes is like really hard, and you have to be like really on the ball to be able to do it that quickly. This took like 40 minutes just to sort this out. Clearly, I just need more practice. I mean, that's really just what it comes down to. Just need more practice with SQL syntax and related questions. There is an issue here of there is an issue here of like if I want to use aggregate functions, It's definitely harder without using aggregates or window functions. So the one that we're looking at now, yeah, pretty much we want to group by the departments. So we can group by, I mean, that's fine. And then group by, order by, group by department, order by salary. But we need to limit the number of, so we can run a subquery that gives us, so yeah, that was a totally different problem that I was working on, but we can run a subquery that gives us the salaries and make it unique, right? Distinct. And then we can natural join on the natural join back. So we get this top 3 unique salaries for each group, I suppose. See, that I'm not too sure about. Top 3 unique salaries, and then natural join back on the employee table to get the employees that have those salaries, and then order by the. So I don't know. You could do something like the following. So let's do something like this. Okay. Employee table, department table. What do we got? These are going to be our employees. They have IDs. Put 7 in here. ID, name, salary, department. No managers. Okay. I guess both of these should be not null. Let's say Joe, Henry, Sam, Max, 1, $85, 80, 2, 60, 1, 2, 3, 2, and 90, 1, 2, 3, 1. Okay. So we have Max, we have Janet, Randy, and Will. Janet, 69,000. Randy is 85,000. We'll just put the 70,000. And Will, oh, okay. Will be at 71,000. Okay. And then the department, IT sales, okay. Fair enough. All right, we're gonna build our schema here. At line 8. Which one? Oh, these also don't need to be integers. I mean, they don't need to be. Unless I'm wrong about that, actually. Maybe these all need to have maybe these need to have, that could be the problem actually. Oh, that worked, okay. That's fine, so great. This could be just 1 and 2. Okay, so the problem that they're asking for here is they want for each, so we can group by department ID, right? I don't really use that very much either. From employee, group by department ID. We'll say as A, we'll say A dot department ID. Okay. All right. We're almost 3 hours in now. Okay. Joe, Henry, department ID 1, 2. What? What does group by do? Oh, that's interesting. Into enables a query result to be stored in a variable as written to a file. Oh, that's useful. But we just want select, right? Inner join, I think, is a natural join. So what does group by do? Huh. Oh, this isn't really a join, right? Column names, alias positions. Okay. But what about T1 name, T2 salary from employee, T1 info is T2, where T1 equals T2? So that's interesting. Huh. So that creates something of a join, actually, if you do it this way. I hadn't really thought about that. That might be easier to use that than what I used. Actually, let's go back to our original. Let's comment all that out. I guess it couldn't go far back enough. I mean, I guess that works. Joe, Henry, Sam, Max. And D name, salary, manager ID. And these could be null. The department. Manager. So Sam had a sales department. His manager was Max. Okay. And third from the top would be, this is 85. I'll make this 200. All right. Third highest salary. So what we had before, and I think very likely issue that we're going to see is this assert seems to need to have its own some reason the comments don't play nicely with the insertions, which is kind of annoying, but that's okay. Oh, okay, that's good. Manager ID. Oh, I see. Both of these need to be ints. That's why. Line 6. This is apparently the issue. I don't know. What is the problem? Groaning. Just groaning. Groaning. What is the issue here? Just sit down and... Oh. Okay. Wow. Wow. Oh. I don't know if left join is going to do what I want here. Could try it. Okay. Have an error in my syntax. Of course I do. Use near create table if not exists employee. Line 6. It's so discouraging. It's insanely discouraging. All right, we're not going to group by. So we have select from employee as A, and we're going to say order by salary in descending order, ID in ascending order, and then we're going to select from that another query, write that A, select from A, and we're going to limit 3 order by, again, salary, this time ascending, so yeah, and also the ID ascending, limit 1, and we're also going to show that as B. So this gives us Joe. So we had from descending, we had 250, 200. Oh, excuse me, this is 85, not. But yeah, so we would have 250, 285 would be at the bottom, would be 3, and then maybe we could make this 85 also. Since we're ordering by ID as well, we're actually not going to have 3. We're going to have 2 will be the cutoff. And then when you take a subquery of that, where now you're ordering by the salary again, but in ascending order, now you're basically going to reverse the list. And if there's any duplicates, so we can make this 50 actually to get some duplicates. And then what will happen is you're going to take the one with the smaller ID, right? If you're ascending ID and ascending salary, if you have duplicate salaries, they'll take the smaller ID, which I think is what you want. And then what you can do from there is you want to match the department ID and the manager ID. So you're going to select from B, you're going to have the ID, the name, the salary of your employee, but you're also going to have now I guess you could do, can you do 3 tables? I don't know, can you do 3 at once? You could try. Well, you could definitely do 1. So you could do with another employee table as B, and then you say, select these things from another table, employee as C, and you could say name, salary, instead of manager ID, we're going to say just department ID. We're not going to do that one yet. But you're going to have C.name, and you're going to have where C.ID is equal to, or B.manager ID is equal to C.ID. How about that? What does that look like? Record count 0. Okay. That's interesting. Oh, well, it doesn't have Henry doesn't have, so this is where you'd use a join. This is where you'd use a join, because if you didn't left join, then you wouldn't get what we're looking for. Gotta use a left join. Yeah. Otherwise, you won't get a null. You'll get a no matching record, and you want to get the department as well. So you can left join again on the department as D. I think and we could say. And b.id is equal to d.id. And then finally it's c.name, it's going to be department name as department name. How about that? I don't think that's going to work properly yet. Line 10. Can you do and? I think it's the join syntax doesn't work this way. I could split into two queries, but the I think the join doesn't allow you to join more than one. No, you can do this. I think you just need parentheses. Where's the search condition? I don't know what coalesce does. Search condition. Oh, there you go. I guess you just need to use no, not the issue. Table reference, join specification. Oh, okay. Table factor, table references. I see. Table name. Table references. Oh, I see. Okay. So you gotta use commas to get multiple tables. Not commas, parentheses. Left join employee SC department is D. Hey, there we go. That's neat. We don't use department ID anymore. Just have salary, D dot department name, department name, manager name. There we go. So just use the left join ID, name, salary, department name, manager name. Okay. Yeah, that's not bad at all. Yeah, so you could use the left join and just. So it would not be a good idea to use a where clause on multiple tables. You'd want to use a join so that way you could have null values. That was part of the specification, but this works pretty nicely for the problem that I was working on before. This is not bad at all. Yeah. Yeah. May not be the most efficient way to do it, but it's pretty good. I think it'll be efficient. I think that there's an optimization that happens. So they optimize the first table, and then the next join is easier. Yeah, that works. All right, now to the problem at hand. Let's get rid of the rest of this. I was just curious if I could use what we just learned, but I don't think we could have used it in that scenario. Okay, let's try that one. All right, totally different SQL statement now. What we want to do is this is what we want now. So, oh yeah, the order by is what we're curious about now. In the select statement, there's order by here. Sure. Order by, what does that do? Column select, no, group by, yeah, okay. So we can refer to them as group by, order by their names or their aliases. Fair enough. Sort in reverse order, descending, order by occurs within a parenthesized query expression, and it also is applied in the outer query. Results are undefined and may change in a future MySQL version. Huh. Interesting. Use of column positions is deprecated because the syntax has been removed from the SQL standard. Oh. Okay. Never mind. Extends the group by clause so that you can specify ascending and descending after columns named in the clause. A, group by, descending. These group by output rows are sorted according to the group by columns as if you had an order by for the same columns. To avoid the overhead of sorting that group. Sorting that group by produces add order by null. Oh, I see. Overhead the sorting. Okay. An implicit group by sorting that is sorting in the absence is deprecated. To produce a given sort order, use explicitly. Okay. What does group by do though? That's what we want to know. So I just want to select from employee group by department ID. So we only get 2, right? That's kind of weird. What does the group do? What does group by do? General clauses used must be given exactly the order shown in the syntax description. For example, a having clause must come after any group by clause and before any Any order by clause, the into clause, if present, can appear in any position indicated by the syntax description, but within a given statement can appear only once, not in multiple positions. For more information about into, see the section. Excuse me. Oh, doing on time. Been at this for hours. Okay, that's fine. A select expression can be given an alias using it as alias name. The alias is used as the expression's column name. It can be used in group by, order by, or having clauses. For example, concat as full name, my table order by full name. Right, that's good. As keyword. Columns, we did that already. Extends group by so that you can also specify ascending, descending columns named in the clause. Use group by. But what does it do? A roll-up modifier, permitting selecting fields that are not mentioned. Extends the use to permit selecting fields that are not mentioned in the group by clause. If you are not getting the results that you expect from your query, please read the description. Okay, that's what we're looking for. Group by modifiers, just handling of group by. Standard SQL, a query that includes a group by clause cannot refer to non-aggregate. But what does it do? Okay. Cannot refer to non-aggregated columns in the select list that are not named in the group by clause. For example, the query is illegal in standard SQL because the non-aggregated name column in the select list does not appear in the group by. So do I need to go like just find the SQL book and learn about group by? Is that what's going on here? Because does it not tell me what group by does in MySQL? I have to go to. It's really annoying. Query to be legal, the name column must be omitted from the select list or named in the group by clause. So group by O custom ID, where custom ID equals C custom ID, O custom ID, C name. From orders as O, customers as C, maximum payment, group by the customer ID. Non-aggregated name column in the select list does not appear in the group by. Oh, okay. So you have to put this name somewhere in here. Oh, it's non-aggregated. Oh, I see. Okay. That's interesting. MySQL extends the standard SQL use of group by so that the selected list can refer to non-aggregated columns not named in the group by clause. This means that the preceding query is legal. You can use this feature to get better performance by avoiding unnecessary column sorting and grouping. However, this is useful primarily when all values in each non-aggregated column not named in the group by are the same for each group. The server is free to choose any value from each group. Okay, so what's interesting is I think group by, what it does is it just takes a whole group of rows and performs aggregate operations on those rows, and then gives you the result of that. So this is mostly for aggregates, aggregating your data. Let's just say SQL group by. What does that do? I don't know where you would learn about this. Huh. LearnSQL.com. Table with 3 columns looks like this. Group by user rating. See if one of these or the other yields a better query plan with the appropriate tool for your RDBMS. Old school way, easier to grok. Group by user rating. So what does group by do? What is where is the documentation for what group by does? Am I crazy? Let's do ID and department ID. What would that do? Okay. That's pretty good. That's kind of what we're after. So this is going to group Yeah, I mean, not exactly what we're after, but it's interesting. I mean, you could also just sort this, right? So we don't really need to do aggregates. We do want something here, though. What does it say? So departments. In the IT department, Max earns the highest unique salary. Second highest earns the third. Okay. So we kind of want to like combine the row. I mean, we could do subqueries for each department. Um, hmm. How can we do this? Oh. Mm-hmm. Excuse me. Well, there's partitioning you can do, right? And then on each of those partitions, you can run queries, I guess. I don't know. I don't know. Hmm. Oh, MySQL is a struggle. SQL questions are a struggle. See, maybe today we'll go over like a couple SQL questions, one or two. What are we doing here? What are we doing here? And I say to myself, what a wonderful world. What do I even do here? What do I even do here? And I say to myself, what a wonderful world. So, one idea is we could, if we had just one table, like we knew the department, it was one department, one table, not one table, one department, and one set of employees for that department. What we could do is, yeah, we take a subquery of salaries, make that distinct, and then use that as a selection again, reuse that to select the employee table where we're using a where clause where the salaries match. And so then you can get more than one of your excuse me, more than one employee with that particular salary. Okay, that's a simple routine. Yeah, that's fine. That works. That gets all you need. Right, you distinct on the salary and sort by descending order. Right, sort order by salary, distinct salary, and then limit to 3 salaries. Then take a it's not really a join of tables, but take only the table, the elements, only the employees that have that with a where clause between 2 tables where the employees match that salary. So you can select from 2 tables, right? That subquery is a table, and then also the employee table. But you want to do that for every department number, right? So you want to partition on departments and perform each of those on those partitions as like sub partitions or something. There might be a way to do this with like, I don't know how exactly to do it, but to like for each department ID, you can run that routine that I just described, and then kind of collect all of those results together at the end. I don't know, there's a way to sort of concatenate rows in SQL, which I don't remember. It's been a while. Excuse me. No. Union, that's the one. There we go. Calculator column or union all should work. So you can union. Let's see what that looks like. Select from employee union derived table must have its own alias. Hold on, we got 7. Select from employee union select from employee. Huh. Huh. What does that look like? Now what's interesting about this is okay, union clause, all right. Excuse me. The result set column names are taken from the column names of the first select statement. Selected columns listed in corresponding positions of each select statement should have the same data type. For example, the first column selected by the first statement should have the same type as the first column selected by the other statements. The data types of corresponding select columns do not match. The types and lengths of the columns in the union result take into account the values retrieved by all the select statements. Take into account the values retrieved by all the select statements. For example, consider the following where the column length is not constrained to the length of the value of the first select. Huh? I'm so confused. Data types of corresponding select columns do not match. The types and lengths of the columns in the union result take into account the values retrieved. So union combines the result from multiple select statements into a single result set. So select, union, all distinct, select, union, all distinct. Okay. Selected columns listed in corresponding positions of each select statement should have the same data type. First column selected by the first statement should have the same type as the first column selected by the other statements. Oh, for the unions. Ah, I see. Because if you have just different data, okay, I understand. Data types of the corresponding select columns do not match. The types and lengths of the columns in union result take into account the values retrieved by all the select statements. For example, consider the following where the column length is not constrained to the length of the value from the first select. So if you union these two, the length is going to be this one. I see. Gotcha. Union distinct and union all. By default, duplicate rows are removed from union results. Optional distinct keyword has the same effect but makes explicit. With the optional all keyword, duplicate row removal does not occur, and the result includes all matching rows from all the select statements. Ah, that's what I was looking at wrong. So union all. And that'll give us what we. Oh, okay, I see. So these are just other select. You just union other select statements, right? Like just union all select. Okay, that's how it works. Got it. Still don't really know what group by does exactly, but I guess we could try to find out more somewhere. Can mix union all and union distinct in the same query. Mixed union types are treated such that a distinct union overrides any all union to its left. A distinct union can be produced explicitly using union distinct or implicitly by using union with no following distinct or all keyword. Order by and limit in unions. Apply an order by or limit clause to an individual select, parenthesize the select, and place the clause inside the parentheses. Oh, interesting. Okay. Use of order by for individual select statements implies nothing about the order in which the rows appear in the final result, because union by default produces an unordered set of rows. Therefore, order by in this context typically is used in conjunction with limit to determine the subset of the selected rows to retrieve for the select, even though it does not necessarily affect the order of those rows or in the final union result. If order by appears without limit in a select, if it is optimized away because it has no effect. Oh, I see. Right, I see, because at the end it's going to be, okay, understood. To use an order by or limit clause to sort or limit the entire union result, parenthesize the individual select statements, and place the order by or limit after the last one. See, I get so confused, or I would get so confused. Like when I read, I'm pretty sure I read this like years ago, and I didn't understand that this is with the context of unions. I want to say years ago I read this, and I was like so confused. Why would they optimize out the order by? But now I understand we're talking about unions. Only about unions we would optimize that out. I don't know. I don't know why I struggled so much in life. Like, it's just so many things I didn't understand. Just poorly explained. It's not that it was poorly explained, it's that it was just a ton of information, and I didn't know where to even begin. And I would just like look up stuff, and I wouldn't be able to find what I need. Yeah, oh man, dude, wow. Yeah. I struggled a lot at university, man. I struggled with everything. Just everything in my life has just been a struggle. Everything. But definitely at university, because I don't know, I think it was just a lot of technology, and I just didn't know where to even begin to learn the technology. Where do I even begin? Yeah, it was a struggle. This is the kind of thing that would be. I'm almost certain I've read this before, and every time I was so confused because I was like, well, why would? Because we're talking about unions, so I didn't know what was even being referred to. Oh man, I don't know. I feel like I need to. If I could go back 10 years and just like start over, learning things. That's obnoxious. It wasn't supposed to be that hard. Wasn't supposed to be that difficult. Oh man. Wow. Okay. Statement without parentheses is equivalent to one parenthesized as just shown. Sure. It's kind of order by. Cannot use column references that include a table name, that is, names in table column format. Instead, provide a column alias in the first select statement and refer to the alias in the order by. Alternatively, refer to the column in the order by clause using its column position. However, use of column positions is different. Yeah, so like if I didn't realize that I was reading a page about unions, I would be just totally confused. Like I would have no idea what they were talking about. But now I have some context. I have an idea. Also, if a column to be sorted is alias, the order by clause must refer to the alias, not the column name. The first of the following statements is permitted, but the second fails with an unknown column A and order clause error. Column to be sorted is aliased. If a column to be sorted is alias, the order by clause must refer to the alias, not the column name. A column to be sorted is aliased. Sorry, I also have these just really dark, painful thoughts from time to time. They're just like impossible to deal with. Sorry, forgive me. It's like, just aggravated. Sorry, I'm trying to keep it together. Yeah, some thoughts I have from time to time are just really difficult. Just thinking about like the past and the present and the future. All of those things just extremely painful to think about from time to time. Certain things. Also, if a column is to be sorted as aliased, the order by clause must refer to the alias, not the column name. For a column to be sorted as what this part? Statement without parentheses equivalent to one parenthesized as just shown. Okay. This kind of order by cannot use column references that include a table name. Column references that include a table name, that is, names in table 1 column name format. Instead, provide a column alias in the first select statement and refer to the alias in the order by. So in the first select statement, you can make an alias, and then you can refer to that in the order by. Alternatively, refer to the column in the order by using its column position. However, use of column position is deprecated. Okay, so I think the idea is that in the first select statement, the other records for the other select statement will get that, inherit that same alias, so you can use that alias in this order by. Okay, that makes sense. If a column to be sorted is aliased, the order by clause must refer to the alias, not the column name. The first of the following statements is permitted, but the second fails with an unknown column in an order clause error. So first as B, order by B, can't use A. Okay. If it is alias, you have to refer to the alias. Okay, that's a little bit confusing, but benefited from your Node.js video. Thank you. I'm glad. I'm grateful. Thank you for letting me know, and you're welcome. And forgive me, because when I live stream, I kind of just like ramble on, and you can just watch me struggle through using technology and slowly losing my sanity. But yeah, that video, I made that like 2 years ago, I think now. So it's kind of cool. Like people come by and they're like, "Oh yeah, it was really useful," and I was like, "I made that years ago." I'm like a different person now. I don't know if I'm a different person now, but yeah. Yeah, you're welcome. Thank you for watching. Thank you for watching. I don't know. I've also thought about like other videos that I could make that are just like things that aren't really well explained when you're dealing with like common technology that people wanna know about. I think a good one, like there's loads of stuff, but like a good one is just like the group by clause. That's one I've been discovering now. It's like, what is transact SQL, but well, I don't know, maybe there's like other people. I mean, other people explain it, right? I shouldn't. Maybe it's not. Maybe it's not worthwhile. I don't know. I just do stuff. Just do things. Let's see. Data across multiple records and group the results by one or more columns. Syntax is group by. Group by with a sum function. Okay. Table called employees, the following data. Select sum as group by department ID. From employees, group by department ID. Okay. 2 records selected. These are the results you should see. Department ID and the sum of the salaries. All right. So I guess it's just for aggregate functions. Maybe I'm wrong. Maybe group by is not that complicated. I was looking at today. It was like, how do I? Because I'm trying to solve this problem over here, and I want to use some kind of way to break things down by department. I mean, could do something kind of unusual, but I benefit even more greatly is how you learn and scroll through information, how you search through for useful information, highlight to figure stuff out. I am a student and employee in cybersecurity, Cisco, and still learning the very basics. Sometimes Google expects you to know half the meaning, explaining a complex thing through more complex definitions. Yeah, yeah, it's really hard, man. It's a struggle. You're a student and an employee. Oh, hey, that's amazing. That's good. I actually, one of those thoughts I was having that was really dark was like how hard it was for me when I was a student. And it's like sad because oh, can I add me on LinkedIn? Is it okay for me to show that? Well, it's showing on the on this here, but I'm gonna push you to push more shorter videos that people look for. No worries. Yeah, I'll add you. Yeah, absolutely. Yeah, I think I may have seen your request on. If you haven't already sent it, send it. There were a couple of people that I saw added requests, and I'll add them. I don't go on. I don't go on LinkedIn that often. I kind of like wait for things to accumulate, I guess, and then I go on there. But I also what is it? On my emails, I get emails from LinkedIn. So I think I saw yours. And I thought that was interesting. I thought that maybe you've been where it came from. But yeah. Finding information is challenging. But I think I think the best thing is if you could find documentation for the technology you're working with, and then you could sort of learn how to work through that documentation. That's really helpful. That helps a lot. That's actually something I'm still kind of learning. Actually, after so many years, so many years. Let's see. Push you to push more shorter videos that people look for. Yeah, I mean, yeah, I guess so. I don't know. I'm thinking about that. Like, I probably should. That's not a bad idea. I probably should. Like, things that simple things that people want to know about that like there aren't like I mean, even the simple things, like there are explanations, but they're not like just like a quick like just here's what this is. I think you know who's been doing something similar lately is this fellow. This guy, I want to highlight he's got a pretty big following, but he does a really good job of like he makes these small short videos, right? These are good. These are solid. I recommend these things. I think, I don't know. I'm assuming because the videos I saw from him I think were explained pretty well in the past, but although I'm looking at these videos, maybe these should have more like he should, yeah, I was gonna say he should definitely have more what's the word, like coding examples, like here's what it looks like when you code it kind of thing. Although that's okay, but yeah. Anyway, okay, sorry, I'm rambling now. Caleb Curry's not too bad, but yeah. Not advertising, but if you look at my videos, I'm making like less than a few minute videos, just explaining one tiny concept that will help people similar to me. Of course, my videos are super basic, but it's just a hobby. Yeah, no, go for it. Yeah, do it. No, that's good. That's good. That's the way to do it. Because people, like, they're trying to figure stuff out, right? Like maybe, I don't know, can I do, well, actually, I kind of already figured out the group by already, but it's super helpful for things that are like not so obvious. I'd recommend it. Yeah, do it. Go for it. Yeah, learning as you go, and then just kind of like, just explaining it, discussing it. It's helpful for other people. So this problem, to kind of return to the problem, if you don't mind, don't mean to be rude, but I appreciate you coming by and saying hello, and I definitely add you on LinkedIn. I'll do that. But what was I doing? So yeah, this is an interesting question. Basically, for each IT department, we want to separate out, get the top 3 unique salaries, match those salaries up with the records that have those salaries, and then input for each of those IT departments in the output those records, sort of union all of those records, I guess. Few questions about that. The resulting table could be in any order. Okay. Well, that's good, actually. If we don't have to have an order, that may not be as hard as I think. It's just, it's the top 3 unique salaries per department. And then for that specific department and those particular salaries, you want to match the records in the original table. And you also want to update the department with its name. This is kind of almost irrelevant to the question. Really, the question is, for a particular department ID, how do we get top 3 unique salaries and then also the people in that department with those salaries? So, well, I want to say there's a way to do this with a join, or a few different joins, something like that. Subqueries and joins. There should be a way to do this, but I don't know exactly how I might achieve this. You can get Also, I want to say probably aggregates and window functions and things could be used here, but I want to try to do this without using aggregates and window functions. But I'm sure there's like, let's see there's partitions. Maybe we can find something for partitions. I know that's a thing that might be useful here. Excuse me. No, so 5.6 looks like it doesn't have partitions. Or maybe it does, let's see. A selection of partitions and subpartitions of an executing statement should be checked for rows matching a given where condition. Partition selection is similar to partition pruning in that only specific partitions are checked for matches but differs in two key respects. Partitions to be checked are specified by the issuer of the statement, unlike partition pruning, it's automatic. Not really sure what this means exactly. Okay, so these are, I guess when you're creating tables, you can create partitions. Yeah. That's not exactly what we're trying to do. I'm not trying to do something you have to modify the table itself to create partitions. How can we achieve this? How can this be achieved? Let me think. We want to. Now this is for each department. Oh, we could do it that way. Oh, that's interesting. Yeah, okay, hold on. If you order by each department ID, and that's ascending, and then salary descending, you get something like this, right? So the top 3 salaries, and then you have a subquery, it's just salary. So what's interesting about that is we want to unique each of these. We want to do it based on, and we want to limit, and we also want to do it based on unique each of these, limit, and do that based on each department ID. So now can we write a subquery for each department? Something like that? These are unique per department, right? Yeah. For that department, the 3 unique salaries for that department. Let's just find like the highest salary per department. How about that? Can we do it that way? Highest salary per department. So we want to compare only to other records with the same department ID. Kind of want to loop over every department. Yeah, some kind of grouping is I think what we would want. How can we achieve this? A union doesn't really make sense because yeah, the union doesn't quite make sense because we would need to union like multiple. We don't know how many unions we're going to need because we don't know how many departments we're going to need. Or it's not a static number of unions. It would be a union for each department, which would be fine, but I don't know how we loop over the number of unions we need. I don't know how to do that. Also, I'm going to close the blinds here, so I'm getting the sun in my eyes. Oh, also my machine stopped, finally. Let's see. How do we do this? Salary from employee, order by department ID ascending, salary descending. So we would want a union of subqueries. Can we do that? I don't think that works. I don't think so. Can you do like a for each? I don't think you do that either. What is available to us to achieve this? What could we possibly do? We only have, so we have select, join, union, and subqueries. How about these different subqueries? So let's see, maybe there's some subquery magic we can do here, or some subquery things we can do. Within another statement, subquery forms operations SQL standard requires are supported, as well as a few features that are MySQL specific. Here's an example of a subquery. So select column from D2. Oh, we could actually, well, that's interesting. So, actually this is not as hard as I think. You could use, I know what to do. I got it. Or do I? Maybe. Can we just get if we just get a subquery, just a query that gives us like the highest salary from every department. So let's see. Select employee or salary from employee, and we just have where select column 1 from T2. Salary, not salary, let's do as A dot salary and A dot department ID, where A dot department ID is equal to select. So I guess it could be any of these. Is that how that works? Or is it equal to column from T2? It's nested. Nest subqueries and then other queries to a considerable depth. Subquery must always appear within parentheses. Main advantages are they allow queries that are structured, so it's possible to isolate each part of a statement. Alternative ways to perform operations that would otherwise require complex unions, joins and unions. Many people find subqueries more readable than complex joins or unions. Indeed, it was the innovation of subqueries that gave people the original idea of calling the early SQL structured query language. Example statement that shows the major points about subquery syntax as specified by the SQL standard supported MySQL. Select where any greater than any, select count no hint from T2 where not exists, where row. Oh boy, look at that. Return a scalar, a single row, a single column, or a table, or one or more rows of one or more columns. These are called scalar, column, row, and table subqueries. Subqueries that return a particular kind of result often can be used in certain contexts, as described in the following sections. There are a few restrictions on the type of statements which in which subqueries can be used. A subquery can contain many of the keywords or clauses that an ordinary select can contain, distinct group by order, by limit, joins, index hints, union constructs, comments, functions, and so on. Subquery's outer statement can be any of select, insert, update, delete, set, or do. Oh, that's interesting. So I don't really know what these things do. What does like set or do? In MySQL, you cannot modify a table and select from the same table in a subquery. This applies to statements such as delete, insert, replace, update, and because subqueries can be used in a set clause, load data. For information about how the optimizer handles subqueries, optimizing subqueries and derived tables, for discussion of restrictions on subquery use, including performance issues for certain forms of subquery syntax. Okay, the do statement executes the expressions but does not return any results. Most respects is shorthand for select, but has the advantage of slightly faster when you do not care about the result. It's primarily with functions that have side effects such as release lock. Okay, so oh, that's interesting. Okay, we don't really need do. I don't know what set does. Oh, you can set a variable. Oh. Huh. Set syntax for variable assignment enables you to assign values to different types of variables that affect the operation of the server or clients. User-defined variables, stored procedure and function parameters, and stored program local variables. System variables. The system variables also can be set at server startup. Set statement that assigns. So I wonder if I can use set statements in my subqueries. Set statement that assigns variable values is not written to the binary log. Excuse me. So in replication scenarios, it affects only the host on which you execute it. To affect all replication hosts, execute the statement on each host. Following sections describe set syntax for setting variables. They use the equal assignment operator, but the colon equal assignment operator is also permitted for this purpose. User-defined variable assignment, parameter and local variable assignment, system variable assignment, set error handling, multiple variable assignment, system variable references and expressions, one-shot assignment, user-defined variable assignment. User-defined variables are created locally within a session, exist only within the context of that session. Section 9.4, user-defined variables. User-defined variables written as var name is assigned an expression value as follows. Examples: name, total tax. As demonstrated by those statements, expression can range from a literal value to more complex value returned by a scalar subquery. Whoa. Parameter and local variable assignment. Set applies to parameters and local variables in the context of the stored object within which they are defined. The following procedure uses the increment procedure, parameter, and counter local variable. Create procedure, begin, declare, counter, do, set. So maybe we can create a while loop in our use a while loop in our function. System variable assignment. MySQL server maintains system variables that configure its operation. A system variable can have a global value that affects server operation as a whole, session value that affects the current session, or both. Many system variables are dynamic and can be changed at runtime using the set statement to affect the operation of the current server instance. To make a global system variable setting permanent so that it applies across server restarts, you should also set it in an option file. If you change a session system variable, the value remains in effect within your session until you change the variable to a different value. The session ends. Change has no effect on other sessions. I'm actually kind of thinking about something else now entirely. So can you multiple variable assignments? I want to know if I can set one-shot syntax internal use only has been deprecated. I want to know if I can set a variable to the results of a I want to know if I can set variables to the results of a Also, where are we? Set statements and SQL statements, database administration statements. I want to know if we can set variables in my if I could set variables in, if I could set the results of a select statement. That's what I want to know. So records. So have multiple records in a variable. Store value in a user-defined variable in one statement, refer to it in another statement. Enables you to pass values from one statement to another. User variables are written as var name, where the variable name consists of alphanumeric characters, dot, underscore, and $sign. User variable can contain other characters if you quote it as a string or identifier. For example, at myvar, at myvar, at myvar. User-defined variables are session-specific. A user-defined variable defined by one client cannot be used, seen or used by other clients. All variables for a given client session are automatically free when that client exits. User variable names are not case-sensitive. One way to set a user-defined variable is by issuing a set command statement. For set, either equals or colon equals can be used as the assignment operator. User variables can be assigned a value from a limited set of data types: integer, decimal, floating point, binary, non-binary string, or null value. Assignment of decimal and real values does not preserve the precision or scale of the value. A value of a type other than one of the permissible types is converted to a permissible type. For example, a value having a temporal or spatial data type is converted to a binary string. If a user variable is assigned a non-binary character string value, it has the same character set and collation as the string. The coercibility of user variables is implicit. It's the same for coercibility as for table column values. Okay, so this isn't too helpful though, because we want variables that could be we want variables that can give us oh, that's interesting. Select statements, oh boy. Each select expression is valued only when sent to the client. This means that in a having, group by, or order clause, referring to a variable as assigned a value in the select expression list does not work as expected. Oh no. So we have A, B, having B. Reference to B in the having clause refers to an alias for an expression in the select list that uses A. This does not work as expected. A contains the value of ID from the previous selected row, not from the current row. Oh, that's interesting. User variables are intended to provide data values. Oh, that's. Oh, I see. Okay, but you could set variables in your select command. That's interesting. User variables are intended to provide data values that cannot be used directly in an SQL statement as identifier as part of an identifier, such as in contexts where a table or a database name is expected, or as a reserved word such as select. This is true even if the variable is quoted, as shown in the following example. So C1 set OK, column unknown in field list, set column OK, select column from T. Well, that's kind of confusing. Exception is principle that user variables cannot be used to provide identifiers when you're constructing a string for use as a prepared statement to execute later. In this case, user variables can be used to provide any part of the statement. The following example illustrates how this can be done. Oh, I see. So if you create a string that's a prepared statement, then execute, then it works. Application programs to construct SQL statements using program variables, as shown here using PHP 5. Assembling SQL statement in this fashion is sometimes known as dynamic SQL. That's confusing. It's like building SQL statements. I don't know about that. Okay, but we don't need to get into all that, or at least I don't think we need to. Hopefully, I don't need to. I don't think variables help us here. That's kind of what I wanted to check. Is that if you could set. I don't think you can store. Excuse me. I don't think you could store the results of subqueries into a variable. Yeah. It's kind of annoying. That's kind of what I'd like to be able to do is just. Okay, so you can have variables in SQL, but they're not, like, they don't store results of your queries. So now this is interesting. Where the any, so we need to go back to, yeah, any. What does any do? Subquery is a scalar operand, comparisons using subqueries with any and or some, all row subqueries. I guess we got to look at all of these. Scalar operand turns a single value. Neat. Comparisons using subqueries. Most common use of subqueries in the form non-subquery operand, comparison subquery. Comparison operator is one of these operators. For example, where select column from T, A is equal. MySQL also permits this construct. This is like this subquery. At one time, the only legal place for a subquery was on the right side of a comparison, as you might find some old DBMSs that insist on this. Example of a common form subquery comparison that you cannot do with a join. It finds all the rows in table T1 for which the column 1 value is equal to a maximum value in table 2. Alright, so column 1 equals maximum column 2 from T2. Interesting. Here is another example, which again is impossible with a join because it involves aggregating for one of the tables. Finds all rows in table T1 containing a value that occurs twice in a given column. Where 2 is equal to select count from T1, where T1 equals ID equals T2, TID. So count the number of times, and we're going to say from table 1, where table 1 ID is equal to TID. Oh. Whoa. Whoa. All rows containing a value that occurs twice in a given column. Oh. Wow. So if you just select everything from T1 where T1 ID equals TID, T1 is T. So these are equal to each other, right? And then count those. So that would be. Oh, okay. So I'm pretty sure I could use the subquery here, and to do what I want to do here. But that's really interesting. So from T1, where they have the same ID, the matching IDs. So this will give you each ID from T, and this is going to be a query of all the IDs that match that ID. Oh, that's really interesting. Okay. Yeah, that's kind of what I want to do. Something like that. Subquery like that. Any and or some. Any of these operators. Any keyword. Follow comparison operator means true if the comparison is true for any of the values in the column that the subquery returns. For example, select S1 from T greater than any of these values. Oh, so I want to say if it's equal to any of these values. But we could do something like, yeah, A salary, A department ID, select all the rows, and I don't know where is going to be. We'll come back to that in a minute. But where, so we could select from A, from employee as B, where A dot department ID is equal to, or where B dot department ID is equal to A dot department ID. So this subquery that we run, this is going to give us all of our, this subquery that we run is going to give us all of our employees that match that ID. Okay. Now we want to say the salary. So we're going to say distinct salaries. And we're going to limit that to 3. So we're going to say distinct salaries from B where the department ID matches A. We're going to take those distinct salaries. We're going to order by, here we go. Let's do it this way. Where that's the case, we're going to order by salary descending. So it's going to be the top salaries. And we're going to limit by 3. Also, I think oh, well. Okay. And where the salary is equal to that. All right, what happens if we do this? And it's any. Version doesn't yet support limit in all any some subquery. No. No. All right. This doesn't really help us that much, but what do we say? So salary department, we're going to select the distinct salaries from employee as B. So this would be a very good, this is a hard question. This would be like really solid if I could do this. Okay, so you select this distinct salary from these employees table. The department ID matches this department ID. Order by the salary, descending salary. So if any of these salaries match, now we should get 7 here, right? 1, 2, 3, 4, 5, 6, 7. We want to limit. So we can't limit this. Version of MySQL doesn't yet support limit and in any sum subquery. No. No. That would make this so much easier. No. What do you mean? No. Um. No. What does sum do? Oh, okay, sum is an alias for any. Oh. Excuse me. So these are all the same. Any, in, or sum. But this is what I want to do. Can I do this on this routine? I think these are not case sensitive also, by the way. No, come on. I thought that might be the case. Oh, that's upsetting. Does it make it so much easier? This will be so much easier. All right. I don't know. How do you do this without the limit? How could you do this without the limit? How to do? How to do? Oh. I thought I figured it out. I thought I got it. I thought I was so smart. Excuse me. Maybe I can do a where clause. Oh, I don't know. Well, Excuse me. Oh, wow. No kidding. Well, this is tricky. Excuse me. I don't know, man. This is quite tricky. Oh, wow. Oh, wow. How to do. How to do. How are we going to use an any clause without a limit? I mean, we could run a subquery, but what is the point? Excuse me. I mean, maybe we can join with this subquery. Yeah, I mean, you could do something like this. I don't know. Let's join. Let's try that. So we could join as B or as C. What does this do? Select from employee as A. Left join with B line 6 as C. On and we department ID is, well, okay, on A dot department ID equals C dot department ID. And where clause. A, yeah, see, A doesn't exist here. The subquery, no, you can't join itself with its own subquery, right? That doesn't really make sense. How about this? How about what if you did something like this? All right, say select A, or just like this, A dot from employee as A, and left join with B dot from employee as B. What does that look like? And then on A dot department ID equals B dot department. ID. Have an error in your SQL syntax. Check the manual. Employee as B on department ID. B equals department ID. A dot department ID equals B dot department ID. A with B. Ah. Hey, there we go. Okay. So, I don't even know what this does, but maybe more information, we can do something with it. So, we have a department ID 1. We have Joe a few times. Department ID 1. And we could say select from employee. Let's just do A dot department ID. But actually, we want all of those, but we want A dot department ID and B dot name, B dot salary, B dot department name, ID rather, and B dot, what is this, 4 things. Salary name, ID, and ID name, salary department ID. ID. Alright, what happens if we do this? Unknown column, B dot department, department, ID. I think I'm getting closer here. I think we could do something with joins. We can make this happen. But it's going to be interesting. So department ID of A dot department ID, and then we're going to left join on B. So what if we distinct department ID? Okay, that's interesting. So we have 1 and 2, and we have, I don't think that's actually the right way to do this. That's just confusing. What if we just did A star, right? What does this do? So this is a join on department IDs. So all of these match department IDs. So Joe matches with Joe, Max, Janet, Randy, and Will. They'll have the same department ID. Henry only matches with Henry and Sam. All right, I think I get it. Sam matches with Henry and Sam. So this will create like a round robin type of deal, where it's like a graph, round robin graph type of thing with only the on the left side you're going to have sort of outgoing edges to other employees that share that work in the same department. All right, now for each of these departments, we can get a what I want to say is I want to get the highest salary for each department, or the highest 3 salaries from each department now. We do that for everything here. So now what if you did something like select from employee, no, that wouldn't make sense. I don't know. Maybe do another left join? I don't know. How do we... Maybe we just want the largest largest salary from each department. How about that? Can you group by? Can you do that? I don't think we really need to save that. So what if we say select from employee, group by department ID. Okay. Now let's do limit 2. What if we select the sum? All right, sum of the salaries. Let's try that. For each group. And we would say A dot department ID. Okay. We'll limit 1. What about that? All right. How do we... What if I just want 3 people from each department? How about that? Like just 3 people from each department. How can we do that? Three random people. Doesn't matter. What if we had what we had before? We picked just... No, man, it doesn't make sense. It doesn't work. No. Ugh. Ugh. I don't know. I don't know. I don't know. I think the join, where we join each person to all of the other people in the department, is potentially useful. I don't know how useful that is, though, really, realistically. Excuse me. Well, you could perform a subquery, take the limit. The where doesn't really make sense, though. No, it doesn't make sense. I mean, you can do something like this. Just do like for the first department, right? So select from employee as A, where A dot department ID is equal to 1. Right, let's try that. And then you can say select salary, distinct, and also A dot department ID. Distinct might not be what we want. Then we want to order by, descending, and then limit 3. Salary. Oops, didn't mean to do that. Unable to find host for provided ID. What? Excuse me. Okay. All right. 90,000, 85,000, 71,000. Okay. That's for a particular salary ID. So then we can say select from employee as B or as A, where this is B. So now we want to get each of these rows. We're going to say B is equal to A dot department ID. Each of these. So can we union? Okay, maybe we do that. Union. Where clause? Oh, no, has no knowledge. So maybe this is a left join, maybe a join. But they don't have no knowledge of each other. line 5. And then this is just on, I don't know. Salary? Who knows? What does this look like? Unknown column and where clause. Yeah, I can make this a nested query, but what would be like okay, I guess. Like this would be a nested query, but it would have to be where can you use nested queries exactly? Maybe just say S1 equals any of these. I don't know. I don't have any limit. We can't use it. We can't use any. I don't know. That doesn't make sense. I want to union these subqueries. How do I, not even union, but just how do I loop through all the salaries of the employees and generate each of these? How do I do that? Where can we use subqueries? So there's where, but that's not what we're looking for. Example of the subquery is the outer query, and select from as a subquery. Say that the subquery is nested within the outer query. Possible to nest subqueries within other subqueries, considerable depth. Always appear within parentheses. So I don't know. Can we do this? I just comma C, right? Like just make this a whole. I mean, it would look something like this. A department and the where clause. No, can't do that. I don't know, man. Oh, okay. Yeah, there's no. How do we do this? How do we do this? How? I mean, you could maybe do a join, and then maybe you could do something like this. So you could say select a dot from employee as A, and left join with B dot from employee as B, right? And then you get select, rather, excuse me, two select statements. And then on A dot department ID equals B dot department ID. Something like this. line 2. Select from employee as A. So actually you would say like, I don't know. What is even the left join? How does this work again? Unknown table B. Okay, there we go. All right, so we can select A from employee A as A and left join with B as B. And can we can't refer back to A in this select statement. That's the thing that's tricky. But here you go. 1s, 2s, 3s, 4s, 5s, 6s, 7s. Okay. And then now you can say something like, I don't know, where oh, also, wait, what? We're missing some columns here. Excuse me. I don't get it, man. It's like, nope. No. Doesn't work. Can't do it that way. Does not compute. So like this is great, but what are we trying to do here? Like we're trying to, there's a subroutine. We're trying to get like a department ID in there. If I have a certain department ID, then I can perform. I could find the top 3 unique salaries. And my thinking is that I could maybe join? No, so maybe you could do it that way. No. How can you can't use any with a limit. And how am I supposed to do this? How am I supposed to do this? How? Ho hum. Dum dum de dum. Oh boy. This is excuse me, difficult and frustrating. Oh. Oh, this is difficult and frustrating. It's maybe not too frustrating, but it's like, I guess it's frustrating that I haven't made any progress in hours. That's difficult and frustrating. How you can't use the limit and the any. Okay, so can you just join on? No, but you can't. That you can't join on that subquery because it doesn't, in some sense, doesn't exist. Yeah. Can't use the any limit. Well, what you can do is if you could get if you could just get a oh, this is tricky. You could just somehow get a table of the salaries, the unique salaries, top 3 unique salaries for each department. You'd have enough. You'd have more than you need. I mean, the problem is using the where clause. Well, you can use something similar to the where clause by using a join, right? You would get null where these things don't match, but you need a table. You need a department ID in order to get the table of salaries, right? Yeah, that's kind of the issue. And my thinking is like, well, you can join your tables. Well, you need an on clause. I mean, you can join them on like nothing, I guess, or anything. I don't know. Excuse me. Definitely should be able to do this using joins and subqueries, but not seeing exactly how to do it, how to achieve it. If you excuse me. Oh, I don't know, man. No idea. No idea. What could it be? I don't know. I don't know. Ah! Hmm. How to do? How to do? Yeah, if you had a specific department ID, you can get the top 3 salaries, the unique salaries. That's fine. But how do you do that per department? Can you join somehow? I don't think so. Um, yeah, but if we join the employees themselves on the department ID, that'll give us sort of sections of each department. Every employee will be related to every other employee in the department. Like, that's useful, but not quite what we need. Um, oh, you know what? Oh, I got it. I don't have it. I mean, you can run a subquery again where you can run a subquery on that table. That might be easier. I'm hoping that's easier. If you run a subquery on that, so select from that table the top 3. Excuse me. No, we end up using the any of again. I don't know, man. I don't know. I don't know. How do we do this? How do we do this? What great difficulty? What great difficulty? I mean, you could do things. You could make things really awkward here. Just to get it to work. You can do something really awkward here just to get it to work, but it's not the right way to do it at all. This is kind of a hack. You can kind of hack this a little bit. Alright, you ready for this? This is very hacked. Would not recommend this. What I'm about to do here. This is dumb. What I'm about to do is dumb. Okay. Alright. I don't know if this will work. If it works at all. Distinct salary. From employee B. Ordered by descending. Limit 1. Yeah, okay. So that's so annoying. I hate how this is, not hate it, but it's really annoying. Trying to get this to be tabbed correctly. So select distinct salary from employee SB where, is this obnoxious? What? It's just, I just want to tab correctly. So when you start typing, it's 1 over for some reason, just really annoying. All right, what we'll do this way. There you go. Now when you tab, it's in the right spot. Where b dot department ID equals a dot department ID. All right. Okay. So these are the highest salaries in the departments. Okay, you ready for this? Or, so it's, you could do or, same subquery, distinct salaries limit 2, right? And then what you're going to do You say as X, or as alpha, we'll call it. So you have alpha. And then what you're going to do is you're going to take that alpha and subquery that, select from this subquery alpha, order by. So now you're going to reverse the order. So the way what you do is you say, first you have order by salary descending, or 1. Then we order by salary descending 2. Reverse the order by salary ascending, and limit that by 1. So we get this subquery alpha, or where clause, unknown column A department ID and where clause. Oh no, can we not subquery or subquery? Oh no. Oh no. We could say C. How about that? Hold on. Oh yeah, yeah. Oh, I see, I see. Or, so you have where A equals salary, or A salary is equal to this. Is that working? It's so confusing. Get rid of the first one. We want to subquery these two, right? So if you'd say, so we get rid of this part, we just say A equals salary, limit 1. Don't call it as alpha. Okay. But now if we select from this subquery, every derived table must have its own alias. Alright. As alpha. But now we don't have, so we lose A department ID. No, come on, really? Why is this, why did we lose this context? Why? Why? This is upsetting. This is just upsetting. No. No. Doesn't work. I want to take this subquery and then subquery this subquery. But how do we... No. 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 I'm gonna get the maximum salary of each department, but we can't get the maximum of 3 salaries. That's not gonna work. No. No. Excuse me. Cannot get... Question. So frustrating. Yeah, SQL is extremely irritating to try to quote unquote program in. It's like the most obnoxious thing ever. It's like, I'm a programmer, I'm not a... Why? Could just do multiple queries and combine them. Like why does it have to be so? Because it's just so restricted in terms of what you can do. Normally with programming languages you can loop over all kinds of things that you might want to loop over, but you can't really do like direct loops in so I mean sort of like so obnoxious. This is the most aggravating thing ever. Excuse me. How do I handle this? How do I fix this? How do I do this? Stop. So frustrating. So annoying. What do you mean it doesn't support limit any? Why not? This would be so easy if it did. And I can't even subquery what I want to query. That doesn't work. How do I... How do I do this? The department ID... This is frustrating. We want the department ID to be... Excuse me. So what's interesting is you can join the tables so that the department ID of, I guess, what you're working with is available. In other words, you don't need the previous reference of the previous table anymore if you join the tables. Something like that. But the problem with that is then you're like, what am I even doing anymore? That's just really confusing. I don't know. Hold on. Let me try this again. Let me do this. Wait. Okay. I got an idea. All right. I have an idea. Ich habe eine Idee. Let's join these tables as we had before. So select from employee A as A, and left join with select from employee as B, right? And we're not going to do this anymore. On A dot department ID equals B dot department ID. Okay. Did this a few times before. Okay. If we do this, now this we can say select distinct salary from this table as alpha and what does that look like? Duplicate column name ID. We can do A's A.ID, A.name, A.salary, A.department ID, and then same deal here, B.ID, A.name, A.salary, A.department ID, and then we can just say, oh no, sorry, B. And we can say select distinct salary from, wait, what does this do? Oh. Okay, so that's interesting. So these distinct salaries from this table. Now we want to say where. Now we want ID as A ID or just ID. A as A ID and B ID. A ID is equal to B ID. Something like this. I'm so confused. Oh, I don't know what I'm doing. Stop. Let's do just select everything from this here. It's department ID. Okay. So we just get everything here, right? And just say distinct. Well, not make it distinct, but just get everything. All right. Now, the idea was that we want to run a query where if we run something on this table, now we have a department ID and an ID. And now we can say, we can use a select from, and we could say where ID equals department ID. How about this? Okay. Alrighty. Now if we select salary, only gets the salaries. Alright. We say distinct salaries. Oh, there we go. That's what we wanted. So here's the deal, right? Okay. This is so confusing. I think it works, but it's just ridiculous. So now we have our IDs and our department IDs. And we only look at the salaries. Well, what's really confusing about this is you have an ID and a department ID. It's very confusing. What is happening? What does this do? What? Well, this is way too hard. This is insane. This is just insane, man. This is ridiculous. What I want to do, I think, is take this as part of our subquery, because now what? What's even happening? I don't know. I don't know, man. Okay. So there's just Joe and Henry, and that's it. They're two different departments. Okay. What if we just say select everything? Joe, Henry, Sam. Okay. Interesting. There should be. So all the rows with the same department ID are. I'm so confused. Like, what does this help us? What is this? Because what we're trying to do is we're trying to select the salary from. There's an employee C where their department matches this particular A department ID. And what we want to do is say, oh, dude, this is so obnoxious. I'm so aggravated. I'm so annoyed. What I'm trying to do is fuse two tables so that you have all of the employees for a particular department in that table. So what you can do now is you can iterate on only one. No, but you already have that. You already have that in the original table. The original table, every employee has a department ID. Why is this so difficult? Why is this impossible? Oh, this is so obnoxious. Yeah, like if this is just like a programming language, you could just loop over the department IDs, and that's that. Just don't have to even think twice about it. It's like, oh, now we're gonna use some kind of join to operate over the department IDs here. Why? Maybe I should use the department table for this, actually. Now I'm thinking about it. Maybe that's easier. Yeah, I guess that helps, actually. I'm thinking about it. So, was that noise? What time is it? No, it's not too late. I was gonna say if it's late, I should keep my voice down, but it's not that late. I don't know. Using two different tables, I don't think it really helps us much either. Because it's the same thing. Like we already know what. There's only so many department IDs in the. I don't know, man. It might make it a little bit more efficient, but doesn't actually help us with the logic here to actually have a separate ID, department ID table. Not really. It doesn't really help us that much because, you know, we just have duplicates here, but it doesn't, like we can, I guess we could get each department value. No, I don't want to do that. That doesn't make sense either. What do I do? I don't know, maybe we should start with the department names or department numbers. So select from, so we'll call it department ID or just ID from department. Something about DDL? I don't know. Okay. So we get each of these records, and then we're going to say, kind of want to do like a for each. We could do like for each ID. So maybe we could do like, I don't know. Each record sequentially, can we do that? I don't think we can. Each ID from each department. We want to basically use like a for loop over the IDs, but how do you even? What? I don't know. How what? What? I can't. No, there's no. I don't know how to do this. Just flat out. I don't know. Just don't know. I don't know. How? How? This is obnoxious. It's the most obnoxious thing ever. I actually hate this. I'd say hated is probably fair, because it's just like hours upon hours of like running in circles where you just like, I don't know. How am I supposed to answer a question I don't know the answer to? What do you mean? What kind of garbage is this? This is what you need to be employed. Why? Why? Yeah, I think the people who study this stuff, like, I think they just go through the discussion and that's it. It's like you just look at the answer and move on. Look at the answer, now you know it. Congrats, move on. You know, there's no value in just spending hours upon hours wondering what you could even do. You just don't know it, right? Like, you just don't know the answer. You probably won't know it unless you've seen it before. That's it. That's basically it. I don't know. I don't know what to say, what to think. It's freaking obnoxious, though. I have to say, it's really aggravating, this stuff. Extremely irritating. Can I even solve this without? That's the thing. It bothers me so much. I have such a hard time. Like, I feel like a cheat if I just go through all the answers, all the discussion parts. But that really is the only way to do it, I think. Like, if you want to do this efficiently, like, you really just have to read through all the problems and then you can solve them on your own because you know the answers already. Like, that's really it. Like, there's no other way. There's just the other approaches would be to somehow find out the answer and then remember it the next time you see the question. Like, there's no, for the most part, you don't really quote unquote figure out these questions. You can sit and guess at it for like hours on end, but for the most part, it's not something you'll be able to see easily. It's very much like a knowledge-based thing, not so much a skill, not so much something that you could spend more time on it guessing until you get it. But what's the point of wasting your time with that? At least that's how I'm starting to feel with these questions. Like, I'm just so irritated. So irritating. It's like, come on, man. Why so much torture? Why be tormented? As you're slowly dying, wasting your time trying to guess at some solution here. So, I don't know if you can do just an outer join without a clause, an on clause. That's kind of what I'd like to do, is just like a cross join. That's one thing. That's kind of beside the point, but I'm not sure if that's all too helpful here either. But the reason why I kind of want to join these things is that if you join on the department ID, for instance, from the employee table, then each department ID you'll get all of the employees for that department. But I mean, like, you can get that anyway. But I guess the reason is I'm trying to, for each department ID, I want to perform a subquery. For each department ID, I want to perform a specific subquery and then union all of those pieces. Something like that. I'm trying to just get the unique salaries for each department, right? The top 3 unique salaries, and then from there you can easily generate. If you have employees that have, you can just join. You can do the other pieces easily. You can join the employees that have the same salary. Actually, I have to be careful with that too. I guess it would have to be the same salary and same ID. Yeah, the same salary and the same ID. But yeah, it's like having a whole bunch of subqueries though, which is really awkward. Same salary and same ID, and what was I saying? What do we just? Okay, all right, we're back, I think. Okay. I think, might have been is because I kept yelling before because I was That might have been why someone knocked on the door. They heard me yelling. They're like, "Is he okay?" No, I'm just frustrated. Yeah, I live in an apartment complex, so people can hear me when I'm yelling. That might have been what it was before someone came by the door. It's like, "Is he okay?" I do want to yell more, but I don't want to alert other people. That's okay. I'll keep that in mind. Oh, that might have been what it was. Someone may have come by the door and wondered if I was okay. Sure. So without yelling that I'm irritated and frustrated and aggravated, I can't figure this out. No ideas. All I got are joins and unions. That's it. Really, that you have to work with, and subqueries. That's it. That's all we have. Each department want to get. We can. I mean, we can. Now here's a question. If you select from an employee table and also the department table, that doesn't help us much. Yeah, you want to operate. You want queries where you want all the employees with a certain department ID, but we don't know what these department IDs are ahead of time. They're from either the department table IDs of the department table, or it's just the department IDs of the employee table. I mean, one of the other works. But can we? I mean, maybe we can use no, because you need a subquery. Huh. How do you? Oh, this is infuriating. This is so frustrating. This is the most obnoxious thing ever. Oh, I gotta stop doing that. I gotta stop yelling. I gotta stop yelling. I've already gotten a bad habit in one day. Bad habit of alerting the neighbors that I can't solve a problem. Nope, doesn't work. Doesn't work. So what I'm thinking is there's a subquery that uses another subquery, but that secondary subquery doesn't have the context anymore to yeah, so there's like nested subqueries that we want to use, and the nested subquery doesn't have the context anymore. But maybe we could pass that context forward, right, somehow. And my thinking is um, basically, I think you take two subqueries now, one of which is you create another table that has the ID, and you join. You create another table. Oh man, is that what you do? Oh boy. Create another table that matches the ID that you're working with. Does that make any sense? It doesn't make sense. None of it makes any sense. None of it makes any sense. It's painful. Oh, it's painful. Excuse me. Brother, this is upsetting, to say the least. All right, so we can write a subquery to get the maximum salary, right? So we try the first one, or just one of these. I'm gonna get rid of the second one here. Excuse me. So it's distinct salary from employee A is B. This is equal to A dot department ID ordered by salary setting. Or now the problem is that when we get this subquery, we lose the context of A dot department ID. So we want to somehow pass this forward into the query so that way we have this something. I don't know, how does it even make sense? Doesn't make sense. Oh, here we are 6 hours later. It's like 10 hours per problem. It's gonna take an eternity. Oh, it's gonna take so long to solve these problems, man. Select star from select distinct salary from employee as C, where C.department ID is equal to A.department ID. Order by salary. I'm so annoyed. So annoyed. I'm just annoyed. Yeah, it's the problem that we run into. Is that you can't. Have an error. Why is there an error? Actually, there shouldn't be an error here. This is What is going on, man? I'm so aggravated. So annoying. This is just so obnoxious. Oh, is it? Okay, that explains things. Not even, I don't know, because I don't know the syntax that well, you know, I'm just kind of messing around with all these different pieces, and so I can't tell what's missing or not missing. Yeah, so that's kind of the problem, that we don't have A.department ID. We could somehow like set a variable or something. Yeah, it's not made for that, the variables. It's not made to do that. Alright, so yeah. We want 2 here, but the problem is that we can't run this subquery here anymore because this is no longer exists. Can we do employee as A or employee as B, comma, B equals C? I don't think this really makes a lot of sense anymore, though. Yeah, they have these tables don't have any reference to each other anymore. No, no. So I want to get this A.department ID into this subquery, so I can subquery my subquery, so I can make the use the subquery in a different way. This is really frustrating. I don't know if we could take a set difference or something. Row subqueries. Exists or not exists. Turns a single row to more than one column value. Row constructors are legal in other contexts. All rows in table 1 that also exist in table 2. Subquery turns any rows that all exists. It's true. That's useful. Correlated subqueries. Reference the table that also appears in the outer query. Yeah, so that's kind of what we're trying to do, is correlated subqueries. I guess I should have read a little bit further. Scoping rule evaluates from inside to outside. X column 2 must be a column in table T2. Renames T2 is not a column in table T1 because select that is farther out. Subqueries and having or order by clauses also looks for names in the outer selected list. Certain cases of correlated subqueries optimized, for example, val in select key val from where. Inefficient, likely to be slow. Rewriting the query as a join might improve performance. Aggregate functions in correlated subqueries may contain outer references, provided the function contains nothing but outer references, provided the function is not contained in another function or expression. Derived tables. Table within the scope of a query. Derived table. Mandatory. Have this table. Explain. Select modifies. I don't know what explain does. Subquery errors. Unsupported subquery syntax. Incorrect number of columns from the subquery. Returns more than one row. Any optimizing subqueries. Place a join with the subquery. Subqueries can be transformed to joins for compatibility with older versions that do not support subqueries. Converting a subquery may improve performance. Clauses from outside to inside the query. For example, use this query. So this query. Outside to inside. Huh. S1 from T1 union all select S1 from T2. Using this query instead of this query. subquery. Select column 1 plus 5. Use a row subquery instead of a correlated subquery. For example, use this query instead of this query. I'm so annoyed. I'm so annoyed. Not any x equals any rather than x equals 1 or x equals 2 equals any rather than exists. Uncorrelated subqueries that always return one row in is always slower than equals. For example, use this query. Uncorrelated subqueries that always return one row in is always slower than equals. For example, use this query. Instead of this query. So this is just optimization, but how do I rewriting subqueries as joins? All right, let's try that. Other ways to test membership in a set of values than by using a subquery. Also, on some occasions, it is not only possible to rewrite a query without a subquery, but it can be more efficient to make use of some of these techniques rather than use subqueries. One of these is the in construct. So where ID is in select ID from T2, can be rewritten as select distinct from T1, T2, where they're equal to each other. The queries select from T1 where ID is not in select ID T1 where not exists, select ID from T2 where T1.ID equals T2.ID can be rewritten as select table 1 from table 1 left join table 2 on table ID. Table 2 ID is null. Okay, left outer join can be faster than the equivalent subquery because the server might be able to optimize it better. Fact that is not specific to MySQL server alone. Outer joins prior to 92, outer joins did not exist, so subqueries were the only way to do certain things. MySQL server and many other modern databases offer a wide range of outer join types. Multiple table delete statements, that can be used to efficiently delete rows based on information from one table or even from many tables at the same time. Multiple table update statements are also supported. Okay. Restrictions on subqueries. All right, so what I want to do is somehow use joins here instead of subqueries. This is so annoying. It's obnoxious. Okay. Let's look at our joins again. So we have subqueries, we have joins. Don't know, man. I don't know. I do not know. Not sure what a cross join does. It's just cross join. Okay, so cross join kind of does what we were expecting. It is just the Cartesian product of these two. Okay. All right. So what do I want to do with this information? I mean, I could cross join all day, but what are we trying to do? Is that particularly helpful? I don't like what. Um, hmm. I don't know. I don't know, man. I don't know. I don't know. How is this helpful? How does it help us, though? Um, yeah, I mean, we could say where A dot department ID, B dot department ID. That's a left join, so a cross join, or on. Not a where, it becomes an on. What is the syntax for cross join? Oh, where did that come from? There we go. Okay. So yeah, cross join, left join, same deal. Do you need an on clause for a left join? I think for a left and right join, you do need on clause. Yeah, you need the on clause. That's kind of interesting. I mean, the cross join's useful, but my question is like, what do we do with the cross join? Hmm. Maybe we can. Hmm, so we can do X and Y maybe for these. We have select from employee as A, where salary of A is equal to select distinct salary from employee as B. So we can make this a sub table. We can select from this subtable where department ID. There's two department IDs. Let's go with the A dot department ID. And then we can operate here, I think. No. No. Nope. No, you can't. This is so frustrating. It's extremely frustrating. This is extremely frustrating. This is absurdly frustrating. It's not working. It's just not working. How does one do this? No. Because you can't use this as a subquery. It's like it's the problem. You can't double up on the limit in the order because that doesn't work because you lose this context, this A department ID context. Even using a cross join doesn't really help you too much. This is so irritating. I don't know, man. Not allowed to keep yelling though because it alerts the neighbors. When no one's home, I could yell all I want, but oh man, what is today? I'm losing my mind. This is terrible. I think I should. I don't know. There was a rule I was thinking about starting to have where I just skip. Just if it takes me more than 2 hours, just skip it. Do something else. Come back to it later. That's obnoxious. Yeah, you pretty much need someone to show you how to do this stuff. Like, there's no way you just figure this out on your own. It's pretty much impossible. Pretty much impossible. So frustrating. Alright, all we have are joins and subqueries and limits and order by and all this junk, but don't have window functions. Right, we're only at 5.6. I don't know, man. I don't, like, how do you... Not a clue. Not a clue. What could you even do here? Hmm. Guess I'm complaining, yelling. Hmm. Yeah, this is extremely aggravating. It's absurdly aggravating. Yeah, I really do think the only way to do this efficiently is just skip these problems, and just look at the discussions. I think that's really it. Like anything else, you're just guessing endlessly for days. Okay, all right. Hmm. Hmm. Oh boy, what to do here? What do we do? Some kind of combination of joins. I guess what we want. We need. Hmm. Well, maybe we can just sort by department in the first place. We could do that. If you just, you could pretty easily. First, you order by the department ID, and then by the salary. That'll give you, and it'll be ascending department ID and descending salary. So what's interesting there is you could join these 3 times. I guess it would be if you took this table and yeah, and you join this 3 times downwards. With a unique salary, not just the top 3. Excuse me. Well, what's interesting is you could update the department IDs. And so you could take the top 3 salaries here. And then you can this have to be from the same department. Well, you could do department ID. Okay. Name, salary. I don't really need the IDs. Just name, salary, department ID. All right. So that's interesting. I think what we can do is we may be able to run this routine Hmm. Um. Can make this be a subroutine also, and not a subroutine, but a subquery. And I guess you just say if the employee name, no, well, you could do the ID. The ID exists here. So you could say something like where if, so select from employee as X, where X dot ID is equal to any of this subquery. Select from employee as X, where X dot ID is equal to any of these. Select from A is A. This part is B. Where this is the case, any as alpha, I don't know. Is that the issue? I don't know where we're getting a syntax error from. Okay, sure. Okay. Employee is A, and then this is as B. The second table, so we're selecting this one, where this is the case. Operand should contain 1 columns. Just do AID. There's more than 1 row. Okay. Oh, there we go. Maybe something like this, like topmost 3 department max salary from X group by department max salary. Welcome back, McTell Wolf. Hello, hello. Welcome, welcome. Select topmost 3 of the department. Well, first off, how do you do that? Max salary. Oh, there is a top command. Wait a second. Is there? No. Is there a top? Oh, that's what I use. That's what limit does. Brother, look at all these jobs. Look at, if you search for the top rows of a table, look at 1, 2, 3, 4, 5, 6, 7, 8. 8 remote jobs. Wow. Oh. I could probably use limit. I see and now it's MySQL. Yeah. I think there's a couple things. I don't have I mean I could use SQL Server I suppose. But a couple things. Yeah, limit would work. But there's also there's an offset too. That's interesting. But there's a limit. But there's also the window, the row number. But I can't use that in MySQL 5.6. I'm trying to do it in this fiddle. It's 5.6 fiddle. Excuse me. But yeah, it's limit. You can use limit, but you can also use. They have window functions too. Window functions as well. But oh yeah, so I got something interesting going here. What I might be able to do is instead of using order by and limit, I could see where department ID I don't know if that'll work. I don't know what that's gonna do. The right syntax. I think the where might have to come before the unknown column. No. Hoping that this. I was hoping that this sub. Um, at this subquery would have some idea about this one, X. Um, hmm. Hmm. Could know about A. I don't know. What does that do? Doesn't know about A either. Oh. I think I understand. Yeah, this is just its own subquery altogether. Because it's a subquery inside of another subquery. So it doesn't have any reference to the previous anything. Hmm. Saying some kind of a group by. I don't know. I don't know if group by really works here because group by gives you one row. And I need like multiple rows. What were you saying? You're thinking top 3 departments, max salary from X, group by department, max salary. I don't know if you can get the, I don't know if you can use a group by to get the top 3 of each department. Wondering if I can just get the salaries of each department, if that's possible. I don't know. I don't know what I can do. I don't know. It's interesting if I get rid of this where clause, it seems to work okay. Or it doesn't work, but it's sort of does what I'd like it to. At least works for the first department, but that's just because the first department's at the top here. What I'd want to do ideally is try to do this for every department, not just the first department. I don't know. If we remove this limit from 3, what happens? I think we just get everybody, right? Yeah. We just get everyone. It's just the employee table. It's not really anything special here. Oh, look at that. Well, I mean, yeah, we already have each employee associated with the department ID. What I'm thinking of is running the routine that I just had there, but like somehow incrementing the department IDs each time, something like that. Yeah, I don't have access to these subqueries. Like if I could make the subquery a join, that would be helpful, but I don't really know how to do that. Hmm. Didn't see all the video. You want the first 3 results by department? Yeah. Yeah. Department top 3 salaries. So companies executives are interested in seeing who earns the high. Here, I'll give you this too. Yeah. Companies executives are interested in seeing who earns the most money in each of the company's departments. A high earner in a department is an employee who has the top salary in the top 3 unique salaries for that department. Write an SQL query to find the employees who are quote-unquote high earners in each of the departments. Turn the result table in any order. The query result format is in the following example. So you have Joe, Henry, Sam, Max, Janet, Randy, Will, which is also the numbers I'm using. There's IT and sales, the 2 departments. Right, they get department IDs. The unique salaries for IT, the top 3 are, so that would be 1. I think 90, 85, and 70. So you get with 4 different people, right? Because 2 people have 85. Joe and Randy have 85. So you got 85, 90, and 70. So you get Will, Max, Joe, and Randy, all 4, because they all have, each 2 of them share one of those unique salaries. And then in sales, there's only 2 people, so you only get Henry and Sam. But 80,000, 60,000 will be the top 2 unique salaries per department. So yeah, what I'm trying to do is get the top 3 salaries from each department. That's like, if I can get that, then I should be able to solve the rest of it pretty easily. But I don't know how to do that. I want to just sort by department ID and then salary. Right, if you do that, oh, oops. So that's kind of useful. So each of these IDs now. So what this allows you to do is to take each person as a single ID and yeah, well, each department ID. If you just operate per department ID, you could get each of the names anyway, but I guess each ID now will give you all the other employees that's related to that person that's in the same team. I don't know if that's much. I don't know if that's any more useful. I don't really think so. But let's at least give you, if you take the limit. So this, I mean, this will give you the, not the unique top salaries, but just the top salaries per department all the way down. And you would want to limit each of these, I guess. Should not be that hard. Let me create the table, see if I can help. Yeah, sure. Go for it. Should not be that hard, he says. I just don't know it. Truthfully, I'm like not that familiar with like all the tricks, things you could do with MySQL. I think it is that hard. I think it is that hard. I think so. How do you get the unique salaries for each? Unique salaries for each department. Well, I mean, I have this. Why would we want to use a cross join for this though? This doesn't seem too helpful. Also, I'm gonna raise the volume, start lowering my voice a bit, so I'll keep my voice down. As starting to get to that time of the night where I should be yelling, shouldn't have my voice too loud. Here. How about this? Line 5, incorrect syntax. Okay. Oh, I see. It's only distinct, I think, on the rows themselves. Right, the salary is not distinct. Alrighty. Well. Stink will not work. Group by will work. But how does group by? Doesn't group? I don't know what group by does. Maybe that's the problem. Maybe that's the issue. I don't know enough about group by. I'm extremely irritated because I cannot seem to find documentation on group by. Maybe that's why I'm struggling so much here. I don't want 8, I want 5, 6. What is 5, 6? Okay, 5, 7, I want 5, 6. Maybe that's the issue. Group by. Fingers are so cold. Oh, fingers are so cold. I'm having a hard time typing. I'm gonna go run them under hot water. Retrieve selected rows from one or more tables. Group by. Bit a piece of my mustache, so I had a piece of hair in my mouth. With rollup modifier. Yeah, I don't know. I think that's the problem, is I need to learn how to use the group by to get... I don't think so. I don't think group by is going to give us what we want. I mean, maybe it's the only way, though. That must be why I'm driving myself mad, and there's no way I can... There has to be something that I'm not aware of that I don't know how to use. Oh, that's so much better. Yeah, I have to go find documentation on what group by does. I think I vaguely have an idea of what it does. Let's see. You know what we can do? We can just run group by a few times and just find out what it does. I don't think it's what. Well, that's the thing, is I don't think it's what we need to do, but it's also one of those things where I'm not making any progress with the tools I currently have, so there's got to be something I'm missing. So the problem is that group by only gives you one row at the end, it seems. Well, that gives you the unique salaries per department, which is useful. Okay, I see what you're suggesting. Yeah, this works. Group by department ID, that will group by department that you'll need. That will join the same salaries. How do we get the first three of each department ID? So this is pretty good. This helps. But yeah, distinct, right, doesn't right, I see what you're saying. For what I was trying to do, distinct didn't work. But now the question is, how do we get the first three of these? The first ID. I could use a variable for this. It's a little weird, but it works. Basically, you can do like limit, and you can set a you can actually use a variable to do this. You use a variable to like the last department ID that you processed, and so then it'll get limit of the first department, limit of the second department, etc. But I don't actually know how to like use like a cross join or something. I don't know. Some kind of a join. This is good, but how do we ditch? How do we ditch all of the salaries that are smaller? Could maybe do a left join, I think, on a limit. We could try that. Yeah, that's an idea. So, save this one, and then we have select from this, which would be a left join, with What I want to do is I want to take, for each department ID, or maybe we can do, all right, where department ID, all right, a.salary is equal to any of select distinct salary let's call that alpha. From employee where as B, where B dot department ID is equal to A dot department ID. We say order by salary descending and limit 3, something like this. I don't know. I lost track of it at some point. Line 4. So group by department ID, salary, order, ascending, descending, and then we want to say we're only going to keep the salaries of this table where I think it might be having we need to have, I don't know. Maybe having instead of where. Or maybe we can like subquery this, I don't know. Okay, what's wrong with my syntax? Can I just say select salary from employee? No. This works, but this doesn't work anymore. How about having? Does it just need to come before the group by and the order by? Oh, okay. Oh, that's interesting. Interesting, okay. Oh no, you can't do any limit, that's the problem. That's I keep trying the same thing over and over again. Yeah, any and limit doesn't work. That's why. Otherwise we're done. Otherwise it's very easy. Yeah. That's why. Oh, I see. But you can join this on this limit. Yeah. But the problem with this limit is that I don't know what the, try offset. Oh, like offset by count, something like that. No, it doesn't really help. I mean, maybe there's a way to do it using offset, but I wouldn't know it. I don't know what I can do with offset to make this work, but maybe, I don't know, I don't see it. Group by order. I mean, this is useful. This gets rid of the duplicates. That's good, but we want, Oh, you know, we can try. No. Well, each of these groups. That was if the limit didn't work. Limit and offset are the same thing, basically, more or less. Limit doesn't work because of you can't use any and limit in the same, so you can't use a limit subquery with any, which is really annoying. But I technically could join, but the problem with the join is that could join this limit, but the problem with the join is that you don't have access to the previous table to know what you're joining with, if that makes any sense. So you'll have like a select from this table join with another table, but this table and the other table, they don't have like a they don't have knowledge of each other. Maybe I can save the count of the group. I don't know, can we do something like this? Oh, I see. Yeah, and we're still gonna aggregate, but we want all the rows. Yeah, we don't want this condition the way that this is described. I mean, it's good that we can get the count and compare it to -3, but how do we One idea is maybe we can give new IDs based on the department ID and the order. Maybe we could do something like that, and then we can filter on the IDs, the new IDs. So yeah. So we have this table, which is good. So we have salary, department ID, and then I guess what we'd want to do is, getting there, but need to filter the first three. Select name, department for employee group, salary, department order ID by name, salary, department ID for employee group by salary, name, department ID, order by department ID, salary, descending. Oh yeah, we can get our names. Get the names. We don't really need the names first. I think what we want to do is actually get a we could get like a row number type of thing. I don't want to use window functions though, but I think if I used a window function that would help here. Can we have window? I don't think we have window functions. Yeah, these miscellaneous functions aren't that helpful for us here. Group by modifiers. With roll up, we don't really need the roll up. Oh, maybe roll up is what we're supposed to use. It's possible. I don't think so. No, not roll up's not what we need. Sum as profit. I don't really want roll up. That's not really what we need. What are aggregate functions that we have available to us? Yeah, that's what we need to do. Count of a different number of values. What does that do? count of the number of rows with a different non-null expression values. No matching rows, return 0. Count distinct results from result of student. Obtain the number of distinct expression combinations that do not contain null by giving a list of expressions. You would do a concatenation of all expressions inside distinct. Oh, I see. Okay. Huh. Interesting. Output the name also, that's the hard part because it'll give you 4 rows for IT. That's not that hard. If you just get the top 3 salaries for each department, then you can just do a join on the employee table on those salaries, and then any matching any matching salary, and then you can once you've joined for those employees. Excuse me. You want to join on those salaries, and then once you've done that, then you can just get the IT. You get the names from the employee table, and then you get the departments from the department table, the department names. So those are just 2 other joins, but the hard part though is that you need to actually get the top 3 salaries for each department, not just all the salaries for all the departments, unique salaries. So this gives us the unique salaries for all the departments, which is good, but we want the top 3 of each of those for each department, which is, once we have that, we're done. But one idea is that if we could, for each department, just write a number, from 1 to however many the department, however many is in the department. Then what we can do is we can basically assign a new ID to each of these salary numbers based off of their departments, and then we can just do a select where the row ID is less than or equal to 3, and then we would be done. Then we would be able to solve it from where I described. But I don't know how to do that. What I was just saying, where I could write an ID for the department. I guess you'd have to count the number of you want to count it's not just the number, like you want to give the salaries that are descending, you want to give them numbers. How would we do that? I don't want to count the number of rows. I want to actually, how about we just say use row number? How about that? So I want to do this without the window though. Replicate, yeah, I want to replicate this. No ranking functionality. Closest you get is to use a variable. Okay. Oh, we could use a variable then. Groupwise maximum. Plump for a null self join. Oh. Okay. There we go. That's tricky. Group-wise maximum, commonly asked SQL questions. Seems like it should be easy. It actually kind of isn't. Often plump for a null self-join. T0 column 3. Okay. Table is T0. Left join table as T1 on T0 column 1 equals T1 column 1 and T0 column 2 equals T1 dot column 2 and T1 dot column 3 is greater than T0 dot column 3, where T1 dot column 1 is null. Get the rows in the table for to know the row with matching column 1 column 2 as a higher column 3. You'll notice this and most other group-wise maximum solutions will return multiple rows if more than one row has the same column 1, column 2, column 3. If that's a problem, you may need some post-processing. 2 maximal values. No other row has a higher column 3. Select column 3 from table as T0, left join table as T1 on T0 and T1 where they're equal to each other, and T1 column 3 is greater than T0 column 3, where T1 dot column 1 is null. So that's really confusing. I don't understand what's going on here. Yeah, undefined behavior. I don't think it's right to use the variable. But the question is, what does this do? What is column 3? Select column 3. How? What? I'm a little confused here. It's kind of giving me a headache with the signals. a headache, but like we basically I want to assign each of these a number based off the group that they're in. Maybe I can just get the third salary in each department, the third highest salary in each department. Let's try that. If I can get that number, yep. After all, not that easy. Fair enough. Now, if I can get the third highest salary in every department, then I'll be in good shape. Third highest salary in every department. How do we do that? Let's try to figure that out. Well, can we get the highest salary in every department? Let's start with that. I think I did that before. I don't know how I did it. I did do that. I said I did this. Yeah. Okay. Let's try this one. Okay. Right. So that gives you the highest salary in every department. If I get the third highest salary in every department, that would be so much easier. Also, we can use this routine to get a better set of things. So yeah. So we get this table. And then we take this table, which is the unique salaries per department, and then we join this on the department. Say excuse me, we can use X. Join this on employee as, or cross join as B on as Y dot department ID equals A dot department ID. I'm not really sure. So annoying. Contain one column. Okay. What am I trying to do here? So for each employee, there's the salary. We're going to match it against, this is the unique salaries by department. And we want to match where do we get the third salary? If we can get the top salary in that department, top of the unique salaries, the top one. So the way to do that would be select from this table, subtable, alpha, where alpha dot department ID is equal to A dot department ID. And oh, Look at that. And that would be order by salary. What if we did limit 3? Oh no, that won't work. Descending. I think it still works, but so the idea here is you said limit 3. So now what's interesting is now you can now here's where it gets tricky. What you'd want to do is you can't really you can't drop this subquery one further. Now you could say it's any, but that's the problem, is that if you say it's any, gives you doesn't support limit any. Now if you could join this limit query with something else, yeah, it's actually, all we really need is the third salary or the second salary, right? Per group, third salary per group would be all we need. Almost there. Yeah, you think you got it? I'm very close too, but I don't think I got it. If I can get the third largest salary from each group, that would be sufficient, because then we could just dump all the other ones. Now I can label, I can cross-join this with the employee table that has a column of just numbers straight down, right? That can give us row numbers, but that's not sufficient. Oh, no, it doesn't really help. I might be able to do 3 joins straight down on this table. And so the idea would be you join these 2 salary tables. And you join them on salaries that are smaller. And on equal department IDs. So that way you would have the first row would be joined with itself and the next salary down in its department. And then you would join the next row and the next salary down, right? And so each row would have the first 3 salaries of each department. And then you only need the first row. Then you can use the clause that I just gave you here to get the first row of every group, which would have 3 salaries across, right, left to right. And then you can use those to find your employee table. Yep, that'll do it. And then you can use that employee table. You can just update it with the correct name for the department. And what do they also want? They just want, and you can strip the ID. So you just need the salary of the employee in the department. Okay, I got it. I think I got it. I did an MySQL. Managed to put a count on each row by department. Oh, you did. Hey, there you go. Select row number over partition by, department ID order by salary descending as I count, salary department ID from web.dbo.employee. Group by salary, department ID as aware, a.i is less than or equal to count is less than or equal to 3. Yeah, there you go, that'll do it. However, we want to do this without using the row number because row number is not supported in MySQL 5.6. But yeah, I was gonna say, yeah, you can. There's a row number. What's it called? Window function that exists in MySQL. Let me show you that. If you go to functions and operators, window functions. These will give you row number, number of current row within its partition. So you can use row number as an ID, and you can partition, as you mentioned, into multiple departments, right? And yeah, and then you can give it. Yeah, there is a row number in MySQL. Yep, it's this one. However, this is in 8. You could use it here. Yeah, all right. I guess for this, they do have MySQL 8 for this, but unfortunately, MySQL 5.6 doesn't have, which is what our fiddle is using. So, maybe I'm wrong. Maybe I should just use what's available. But yeah. So all right, let's do what you suggested. So we'll say, or we'll do it. Yeah, we'll use a row number. So you can do row number as R, and it's over. We're going to partition. Or window is going to be order by value. So we're going to say over clause. Over window spec, window name, partition clause, order clause, frame clause. Partition clause indicates how to divide the query rows into groups. Window function result for a given row is based on the rows that partition. Of the partition that contains the row of partition by is omitted. There is a single partition consisting of all query rows. So we want partition by expression. So we're going to partition by and the expression is probably we want department name or department ID. Excuse me. We have a.name, a.id, a.name, a.salary. All right, and we could also say a.department name, department ID. Let's see what this gives us. Start with this. Okay. So this output's really ugly. 1 Joe, 2 Max, 3 Janet, 4 Randy, 5 Will, 1 Henry, 2 Sam. Yeah. And you can also order by. And then order by, so partition comes before the order. Yeah, so we're going to order by ascending, and we can say salary. Now what's tricky here is descending. We got to be careful about here though is that we want to use unique salaries. Can you use a distinct salary? We could try that. I don't know if that'll work. We could try it. No. Okay. So we want to also have to be careful because we want the unique salaries here. 1, 2, 3. Right, you see there's Joe and Randy. They have the same salary. So we want 3 unique salaries. So we've got actually, it's not going to be from employee. It's going to be from what we had over here before, which was the group by. So we can from select department. So we can actually, now we don't need the names anymore. Just need the row, salary, and department ID. From as a, and this can be select department ID, and we'll call it B, and b.salary from employee as B, and this is going to be go back to A. So department ID salary group by b.department ID salary, and then order by department ID ascending and salary descending. Now if we try that, it gets a little more interesting, right? So there's 1, 2, 3, 4, and 1, 2, and we're going to say from where R is less than or equal to 3, or A.R. Really? Okay. I think you've got to use a window clause or something. So now we have the departments and we have row numbers, and now we can select from this table, as X, where X.R is less than or equal to 3. Need a first yeah, select from, yeah, I think so. So now we have each department's 1, 2, 3, and 1, 2. Yeah, there we go. Now we can use this and say we can cross join. So select from employee as alpha, cross join as beta on alpha.salary equals beta.salary. Okay, now try that. Joe is 8,500, 85,000. Oh, and alpha.department ID equals beta department ID. Forgot that part. Also need that. So that should give us 7. So the R can be recognized after you close the closing parentheses. Yeah. I see that. So we should have now 1, 2, 3, 4, 6, 7, 4, 5, 6. So we have Joe at 85,000, Henry at 80,000, Sam at 60,000, Randy at 85,000, Max at 90,000, and Will at 70,000. And now we just need to We don't need the, so we only need the department ID, salary, and employee name. So we could say department. So we can say alpha.department ID, alpha name, alpha salary. I don't know if these are, I don't think these are case sensitive, by the way. I think I can say ID here. Oh. And finally, we want to left join, as is going to be as T. We'll call it T. Left join on the department table. On department ID on T dot department ID department elemental PQRST. We do S and T. ST on S equals T. I believe that will mess with the names of the same salary. How if I change ID? I think I just have to select from oh yeah, look at that. That's interesting. They're not case insensitive though, because employee, the tables are not case sensitive, or yeah. What did I do? Hold on a second, what? Department ID. Oh, the department table is just ID. Got it. Okay. Now we have sales, and now we can rewrite this as name is T name, S name is the employee name, and then the salary, S salary. And this is as department, S name as employee, and S salary as salary. I think we got it. Hey, there we go. There's only one example test case. There's only one. Should we go for it? I think we go for it. Hey, very good. Got there. What kind of question is this, man? It's not cool. Yeah, we did it. But part of the problem here is that we had to use a row number. I don't think if we didn't have to use a row number, or no, if we couldn't use a row number, I think we'd be in a tough spot. We'd have to figure out how to perform this row number over this partition ourselves, which there must be a way to do it given that they've implemented it, but yeah, that would be extremely challenging. This would be a really hard problem to do in 5 minutes. Good job, man. Thank you. You too. We did it together. I was going nuts. I spent 8 hours on this. Oh, it's terrible. Yeah. Well, part of that was actually working on another problem, but I didn't work on that problem for that long. I don't think I could have done this without using a row number. Let's see what other people have. We have a lot of cross joins here going on, though. Maybe it's not as efficient as it could be. Without group by or order by. Best solution, clean, easy, no subquery, mytidy solution, dense rank function, window function, subquery, and join. Whoa. Okay. Wow. Be impossible because there are more than one salary with the same value. Let's see. So, name, department, oh, I guess you don't need to use as, okay, salary, department employee salary, from employee, join department, on department ID equals department ID, employee ID is department ID. Okay, where 3 is greater than select count distinct salaries from employee 2, where their salary 2 is greater than salary E1 salary, and department ID is equal to department ID. Oh. Read about correlated subqueries here for each row of the outer query. Oh man. So this is your, okay, count distinct salary, that will work also. And this is interesting. How does this work? So 3 is greater, so as long as you have less than 3 for the count of the distinct salaries, so the first salary should be 0, so this is where so you can take these distinct salaries where, oh, I didn't even think about that. Oh wow, I'm so dumb. Not dumb, I shouldn't say I'm dumb. I should say I did not even consider something like this. Man, I'm so bad at SQL. So bad at these tricky problems. So you could take the distinct salaries, a subquery for all of the, so it's a subquery on the department IDs where they're equal, right? So you're looking at all of the rows that have the same ID as the one you're currently interested in, right? The correlated subquery. And you're also checking to see that the salary, excuse me, this E2 salary is greater than that particular salary. So these E1 salaries are arbitrary or random, right? But E2 is greater than that salary. Okay. And actually E2 is every, oh, this is really interesting. So this is every salary with in the same department, and you say, okay, all of those that are larger than this particular salary, and we're going to use only the distinct ones, right? So when the salary is the same on this side, you get the same count, right? So it doesn't matter on the right side if they're distinct, but on the left side they're distinct. So how many distinct values are larger? We don't care about when they're equal to. So when they're larger, what this is going to give you is it'll tell you how many salaries are larger than each salary. You're going to process each salary at a time, and it'll tell you how many in that department are larger than that one. Oh, you could go smaller too if you wanted to. And then just flip this over. And so when you find a salary that has less, or excuse me, when 3 is greater than this amount, so let's say all of the other salaries are larger. Yeah, so E2 is where E2 is larger. You're going to count all the other salaries are larger than E1. So in that case, you have a lot of things that are larger than E1. That's more than 3. But when there aren't that many things larger, I see. So when there's only 2 things larger, that's the third. When there's only 1 thing larger, that's the second. When there's nothing larger, that's the top salary. Right, oh, that's interesting. So you can count how many distinct salaries are larger, or you can also do how many are smaller. If you count the number of smaller salaries, and if the number of smaller salaries is, oh no, you can't do it that way, because if you do the number of smaller salaries, then you don't know. You would need to know how big that group is in order to. Yes, this is something like I'm not used to working in SQL like that. Like there's so many restrictions. Like when you're programming something, you have, like you could tell how many are in the group. Like you wouldn't. No. So you can't actually do it the other way around. If you do it the other way around, you would need to be. If you counted the number of salaries that are smaller, then you have a problem because you don't know how many need to be smaller how many are smaller than the first one. It would have to be the whole group, but you don't know how many they're in that group. Yeah. So you have to count how many are larger. If there's none larger, wow. So that's really interesting. Okay, that's super clever. I didn't think about anything like that. I don't see how that where will work, but it works. Yeah. I'll explain. I'll show you. So the idea. So this is definitely better than what I did. Oh brother. I shouldn't say that. Oh man. So I just okay. So we'll say alpha and beta, right? So we'll say select from employee as alpha, and we're going to say, and then we'll come back to that in a second. So where, we'll have a subroutine here. And we want department, so we can say alpha dot department ID as department. And again, I think we can do this lowercase. Well, actually, let's just see. Oh, yeah, you can. Okay. Department ID is department, alpha, name as employee, and finally alpha.salary. Okay. And then we're going to say where from employee as alpha, where the following is the case. So you can say 3, right? 3 is greater than select the count of distinct salary values from, we say beta.salary, from employee as beta, where, now here's the tricky part, when the alpha salary is greater, excuse me, when the beta salary is greater than the alpha salary. I think that's all you need. And the way this works, the idea, oh, and you have to also say and beta department ID is equal to the alpha department ID. This is super clever, but yeah, I mean, it's one of those things. So the idea is, let's see if it executes. Okay, I got it wrong. Here you go. So the idea, oh wait, why did I get it wrong? Oh, we need, I might have forgot that. What did he do to get the name? Oh, we need, could just do a left join. Well, yeah, I guess we left join with the department table. Did I do that correctly? I might have Made a mistake. I have an error. The where clause. I don't know, this is kind of awkward. I don't want to select again. What did he use? How did he do this? Oh, he joined in the department D. I didn't see that. Oh. Also, you don't need to use as. Use X. So if you join on X, X name department, and now you have where. Okay, you could do select join where. What does that do? Hold on, what am I missing? Oh, on. Okay, I missed that. Yeah. Join on. So we could do the join on x.id equals alpha.department ID. Oh, that's interesting. And then it works. I would normally say something like from employee alpha and join department X on xid equals alpha, and then where. Okay, so you can put a where after the join. Okay, I didn't think about that. So yeah, let's submit that, see if it works. I'll explain in a moment what's going on here. Okay. It's actually slower than one that I had before. Okay, of course it is. That's great. No kidding. No kidding. So anyway, the reason why this works is when you're so this selecting from the employee as beta, right? You're taking the distinct salaries from the employee table, right? Very small code. Yeah, that's super succinct. That's really clean. So what you're doing is you're taking the salary from the employee table, right? And you're taking the distinct salaries. Also only from the same department as alpha, right? So that's the correlated subquery. Means that you're only considering alpha's department ID. So this is only going to be the distinct salaries per department, right? Which is what we wanted before. But what's interesting about this is that each salary in alpha is going to be considered one at a time. And we're going to look at all the other salaries in that department and say how many of them for each salary in alpha, how many of the other ones, and also we don't use greater than or equal to, we use greater than, strictly greater than, so we don't consider it self, right? Self won't matter. And we count how many ones are larger, right? So we count how many other salaries are larger than the salary you're currently looking at, right? Now, the highest salary has nothing larger. The second highest salary has one thing larger, right? The highest. The third highest salary has two things larger, right? The two highest. So what this is saying is that we're going to count for each department, each salary alpha we're going to count how many other beta salaries are larger, and the alpha salaries where you only have 0, 1, or 2 salaries that are larger, those are the salaries we want to use, right? So we use the salaries from alpha such that there are 0, 1, or 2 distinct other salaries that are larger. That's what's going on here. That's what how you would express this, how you would say it. And this also works for the salaries that are duplicated because we're using distinct salaries, and we can, even though that we have the duplicates, we can say, oh, there's only 0, 1, or 2 that are larger of the distinct salaries. So it also works for duplicates too, which is really interesting. It's like really clever how this was done. So yeah, I was nowhere near realizing what was being done here. But yeah, I guess the simple idea is that you can you can process your salaries by the department ID, and you can actually count each salary. You can count how many other salaries are larger, how many other unique salaries are larger than this particular salary. And then from there you can figure out the relative position of this salary to the other ones based off how many are larger. If there's, as mentioned, if there's only one larger, if there's 0 larger, that's the highest. If there's 1 larger, that's the second highest. If there's 2 larger, then that's the third highest. And then we don't care after that. So really clever approach. I was nowhere near it. I was so frustrated. I was so upset. We don't need to use row number or anything. It's cool, but not easy at first sight. No, not at all. I was nowhere near figuring out the solution. I was getting so upset too. And we finally figured it out together here, but oh man, how many hours have I been on this? 8.5 hours. I'm so bad at it. I'm not bad. I don't even know what to say about myself here. I've like no excuse. This is one of those things though that like if you didn't know about this technique, this trick, like you'd never figure that out on your own. I don't think so. Yeah, it's just a really clever way of ranking values within the same department. Super interesting. Super interesting. This, by the way, is probably how you can implement your row number too. Something like this, where I take that back. I take that back. The problem with the row number is that you actually have to like increment something, so it's kind of challenging. You don't actually have the ability to like increment things in SQL. Really interesting though. But yeah, this is a very clever way of getting like subsets of departments, subsets of groups. Amazing. Amazing. Too specific. Yeah. Well, this is really useful to know, because this is really good for like other types of problems, where you want to get a certain amount of, like basically you have multiple groups of things, and you want to get like the first of a few or the last of a few or something. You can reverse this to get the last few items of the group too. You can use a slight modification of this. Although they have to all be like lexicographically ordered. In other words, comparable, lexicographically comparable. But yeah, you want to get the last 3 salaries, the last 10 salaries, or the first 10 salaries, and all that stuff. You can do that. You can modify this slightly. So yeah, pretty neat. All right, I'm gonna go. This was kind of brutal. This is like very brutal for me. Dude, I spent 8.5 hours on this. And we figured it out. We got it, but it was rough. That was a rough one. This one I think will be kind of easy. And then we'll have the first 200 solved, and that's 10% of all of LeetCode. Yeah, man. I don't know. I think we're cruising right along though with these hard problems. Yeah, man, that was rough. That was hard. That was so hard. Well, thank you, Mr. Maytel Wolf, for coming by and saying hello. And also there was Hamza Abid came by too. So I'm gonna get off here, but yeah, man, there was no way I would have figured that out. Like, there's just no way. I would never have thought of that. It was, yeah. I don't think I'll ever figure that out. That you could use a subquery like that to get the relative position. It seems so obvious now, but like how? I wouldn't have thought of that. No way. No way I would have thought of that. Also, it's funny at the end there. I tried to not funny, but interesting at the end there. I tried to recreate what he wrote, but I couldn't think to put the join before the where clause. So that was kind of an interesting thing too. There's just like a join just thrown right in the middle there that I missed. But yeah, you could do select join where. Yeah, I guess it'll just be like as I practice more of the SQL questions, I'll get more familiar over time with different tricks that you can use. That's a really clever one. That's a clever one. Okay, all right, I'm gonna go. So thank you again for watching. Talk to you soon. Enjoy the rest of your day. I think tomorrow I'll be on as well. Yeah. Do I have anything else to say? I have no idea how I would have thought of that. I never would have thought of that. I don't know. I'm trying to think of like, not knowing that technique, it would be hard to achieve. Yeah. I mean, what we did was sufficient. Get a row number and count, because that's basically what that did. See you soon. Yeah, see you soon as well. I'll ponder like how I could have figured that out, that technique. I don't know. I think that's something you come across over like a lot of years or something. It's like just somebody somewhere realized that you could do that. I mean, again, it's like seems really obvious now, but it's definitely not obvious like to someone who hasn't considered that. So, all right, take care. Talk to you soon.